morning.
Good morning. What's all this? Your results. Congratulations to all. I'm confident you'll all achieve your goals. So, young man, what are your aspirations?
I want to do robotics, ideally from the Bust Institute in the US.
And you, young lady?
Sir, I love kids and I would love to learn pediatrics. I feel Boston is the best place for that.
Sumit, what about you?
Back home to India for medicine.
Good. I'm sure you'll all achieve your aspirations, be it in India or anywhere. Keep in mind, your first challenge is the entrance, whether it's IIT, JEE, SAT or NEET. You have to learn from the masters. Brilliant Qatar is the passport to your success.
We undertake coaching for regular and repeat batches and tuition for board examinations. Brilliant Education Centre, Doha, Qatar.
Hello everyone, am I audible? Can you guys confirm on the chat box? I should see a yes. Hi Gayatri, hi Vinod. Am I audible to you people? Am I audible to you people? Vanisha is here, yes sir, yes sir. Alright guys, I welcome you in online classes with brilliant group of institution Doha, Qatar, and today we're gonna slay every question I have in the board, and of course you're gonna drenched in the concept of physics. Let me tell you, you're gonna be inside water but you're gonna be definitely breathing fine. Alright guys, without wasting time, let me go ahead with our first question on the board. Is it clear? You guys are all right. All right, guys. Am I audible? Am I audible? Yes, you are. Perfectly all right, guys. Let me go with our first question. Here I have on the board. All right, guys. You have. Write the special name for the coil AB, which has many turns of insulated copper wire. All right. And you're going to tell me, sir, of course, I know this. This is a solenoid. Perfectly all right. And list two factor on which strength of the magnetic field produced by AB depends. They're asking on what factor does the strength of solenoid depends. I mean the magnetic field produced by the solenoid depends. And on the third part they're asking what is the effect of placing an iron core in the coil AB. Let me tell you guys, these questions are picked from the previous year papers, and I'm gonna discuss all the concept based on solenoid step by step. There I go with an answer, guys. Solenoid. If you're gonna ask me what is solenoid, I will answer you. Solenoid is a coil of many circular turn of insulated copper wire wrapped closely on a shape of cylinder, right guys? After that, you're gonna tell me when I connect a solenoid with a circuit consisting of a battery and a key, one end of a solenoid behaves like a magnetic north pole and other behaves like a magnetic south pole, just similar like a bar magnet. All right guys, here you go. You have a coil of many circular turn of insulated copper wire wrapped in a shape of a cylinder. This is the definition which I want you guys to put in a paper. Of course the question will appear, and you have this cylindrical surface. You are wrapping the wire, right, and it is giving a shape of a cylinder. When I start passing current over here, what happens? You're gonna tell me, sir, one end behaves as a magnetic south pole and the other end behaves as a magnetic north pole. Next step, if it is behaving like a magnetic north pole and south pole, of course the field gonna be similar as a bar magnet, ain't it? Of course it is. There you have. The field line is similar as a bar magnet. Externally start from north to south, internally from south to north. There you go, beautifully done. This was the first part of the question, guys. The diagram is really important. Don't draw your ultra legendary diagram. Make sure to have one time practice how to draw this diagram. That's the reason I came up with nice PPTs. All right, guys, diagrams are important. You know it really well. Perfectly all right. The next part of the question, on what factor does it depends? You're gonna tell me, sir, it depends on the strength of solenoid depends upon the number of turn on the coil, right? More you give this number of turn, the strength will be keep on increasing. I am talking about magnetic field produced by a solenoid. You're gonna tell me, sir, it depends upon the number of turn. Perfectly, all right. Magnitude of the current, it depends upon the magnitude of the current. More you supply current over here, more will be the field, right guys? All right. What does the parallel lines of force inside the solenoid indicates? Here you go, another question on the board is like, on what does the parallel lines of force inside the solenoid depends? Once again, what does the parallel lines of force inside the solenoid indicate? They're asking what does it indicate? Which part is indicate? Guys, can you see over here parallel lines? Visible, right? Now they're asking this parallel line depends, what does it indicate, right? You're gonna tell me, sir, parallel line indicates uniformity in the magnetic field, right? If the lines are closer with each other, you're gonna tell me, sir, magnetic field is stronger. On the other side, you see the lines are making gap, that meaning the magnetic fields are weaker. And what happens if the field are in the form of parallel straight line? You're gonna tell me, sir, it gonna be same, constant, uniform, right? You guys are getting me? There you have the answer. The field line and the solenoid are in the form of parallel straight line. This indicates that the magnetic field is same at all the points. Guys, these points are so important. From here, definitely some questions gonna be falling, right? Now, how you trace these questions, guys? After this live session, the video will be available in YouTube. You need to visit once and study. All right? All right. You got me this point clear? Now, electromagnet, they're asking what does the term AB mean in the previous question. You check back the question later, all right? We know it is electromagnet. And what was electromagnet? In the strong field of solenoid, what we gonna do? You will tell me, sir, you will take a magnetic material and you will insert it inside. What happens then? You're gonna tell it magnetizes. If it magnetizes, that's what it is, an electromagnet? Exactly, yes, right? So what is an electromagnet? You're gonna tell me, when a piece of magnetic material like soft iron, when we will take soft iron, what we will do with the soft iron? You're gonna tell, sir, that soft iron, I will insert inside a strong field of a solenoid. There you go. There you go. You insert it in a strong field of a solenoid. When it happens, it will start magnetizing, and the magnet so form is called, electromagnet. Very important. You guys are getting me, yes or no? You guys are getting me. I should see lots of yes on the chat box. Am I? Can I? All right, all right, all right, all right. Now next case is why we are using soft iron. Why you are using soft iron? You're gonna tell me that, sir, yes, lots of yes. A bit delay here, but lots of yes. Thanks everybody. All right. So you guys are getting me right. Why we are using soft iron? Why we are using soft iron in order to make electromagnet? You gonna tell me that, sir, because soft iron has a property of getting magnetized as soon as it starts receiving current on the circuit, and if you switch it off, it will go back to its own state, that is soft iron. What I mean over here is that as you switch it on, it will become electromagnet, right? It will start gaining, instantly it will start gaining magnetism. As you switch it off, it's gonna instantly lose the magnetism and back to soft iron again. So here you have the write-up, a very proper write-up. See it properly. I'm giving a side. The soft iron of a bar acquires the magnetic property only when electric current flows through the solenoid and loses the magnetic property as soon as the current is switched off. Very important, guys. The question appears in exam. You know it really well, right? Now, strength of this particular electromagnet depends how you will change the magnetic field associated with this electromagnet. You're gonna tell me, sir, it depends on number of turn. Perfect. It depends of amount of current flowing in. And last case, it depends upon nature of material. The first one is number of turn, the second one is magnitude of the current, and the third one is nature of the material. You guys can definitely relate about number of turn, right? More number of turn, more will be the stronger will be the magnetic field. Magnitude of current, more current you supply, magnetic field will be stronger. But the third point over here, it depends upon the nature of material. It's a little bit of crucial to understand, guys. You're gonna tell me that, sir, we are using soft iron. What happens if we use any other material like steel? What happens in steel? You're gonna tell me, sir, steel will retain the magnetism for very, very longer time. Very, very longer time. Perfect, guys. Perfect. I'm getting the answer. Rahul and Vanesha, Karthik. I'm sorry if I haven't asked, called somebody's name, but I welcome you guys with all my heart, soul. Here you have the next part of the question. The magnetic field in a given region is uniform. Draw a diagram representing it. Draw a diagram to represent it. Uniform magnetic field line. Just now we have seen what you will do. You will draw this, right? Drawings are important, guys. Drawings are important. Diagrams are very important. All right. So you will see this. If I see it very closer to it, you're going to tell me, sir, in this path, they are parallel straight line. What does the parallel straight line indicate? Just now we have seen in the theory that, guys, if the lines are parallel, magnetic field gonna be uniform. Magnetic field gonna be uniform when they are parallel. When they are parallel. Very good. Very good. Let me see the next one. The magnetic field inside a long straight solenoid current carrying will be same concept. Same concept. They're asking inside the solenoid. Just now we have seen inside the solenoid it is parallel straight line. Just now we have seen inside the solenoid it is parallel straight line, sir, guys. If parallel straight line, what should be your answer? You're gonna tell me, sir, D will be the answer. It's same. Perfect. Arpendu. All right. Aradhya Groshal. Very good. Everybody welcome. Everyone welcome. All right. We gonna drenched in the concept of physics today. I swear. Let me see the next question. So this question is very much familiar, right? You have seen this question in your board paper. Do you? Of course, yes. All right. The question is, you have 3 points A, B, and C, and it is a solenoid. You have a 3-point A, B, and C. This is a solenoid. And the question asks is, where is the maximum magnitude of the field is? In other words, if I make it very simple, you have 3 points given. In these 3 points A, B, and C, where is the magnetic field is stronger? I want you guys to comment in the chat box. Let me see the answer. Yes, guys, let me see the answer. Where it is A and minimum at B. All right, all right, all right. All right, so you guys are getting the content today will be really, really excellent. You're gonna love it as I proceed ahead in the class today. All right, so of course it will be stronger in A. Now many people will say, no sir, it should be stronger at C. I will ask why. You're gonna tell me, sir, the field lines are crowded at the poles. No sir, it is not like that. In this case, a bit different. If you have a close look in this diagram, you're gonna tell me, sir, it is much more crowded in the center if I compare with the other side in the poles. Yes, you guys are getting it. So therefore it will be maximum at A. On the other side, the field lines are having a gap. Your criteria is to see where the field lines are more closer. The point where field lines are closer, the magnitude will be maximum and vice versa, right? So over here it is very closer. So you're gonna tell me that in the center, magnetic field will be stronger. You guys are understanding me? I should see a yes on the chat box, and it should be minimum in B. Why? Because they are having a gap. I have written beautifully the answer for you. I am giving a side. Can you see the answer? It's such an clear cut written. All right, all right. Perfect. Lots of yes. Lots of yes. That's really good, guys. That's really good. All right. Let's see this question, okay? Let's see this question, the most important question. Let me start solving it. It's time to solve few questions. There you go. You have it, right? 3 resistors connected as shown in figure through 5 ohm. A current of 1 ampere is flowing. What is the current through the other 2 resistors? All right. Let me see. Guys, in this 5 ohm resistor, this is 5 ohm, all right? In this 5 ohm resistors, what is the current flowing? 1 ampere. I'm writing it over here. What is the current flowing in this 5 ohm resistor? You're going to tell me, sir, 1 ampere. It is given in the question. Now they're asking, what is the current in this 10 ohm resistor? This is 10 ohm. What is the current in this 10 ohm? And what is the current in this 15 ohm resistor? I will frame the question for you, and then you have to tell me the answer, all right? Let's see. Everybody got the question? They're asking current in, once again I'm explaining the question. The current in 5 ohm resistor is 1 ampere. Current in 5 ohm resistor is 1 ampere. What is the current in 10 and 15 ohm resistor? One of the most complicated. Understand the format of the question, guys. You don't have a potential difference given, and you have to calculate current in parallel, understand, intercept the format of the question. All right. Now see how to solve. You're gonna tell me, sir, my approach for solving current will be I is equals with V divided by R, right? So let I consider this to be R1, let I consider this to be R2. Since I consider R2, I will take it R2, so current will be I2. So this current I will consider as I1. All right. Now, what should be the next approach over here? You're gonna tell me, sir, you have to apply like that, like I3 will be equals with V divided by R3. So this is R3. All right. Now, one thing I'm very clear over here, it is a parallel connection. Of course, the potential difference should be same. Now, many ultra legends over here will do this mistake. Okay, get this mistake. Get your mistake first. All right. Many of our people will do this mistake. What is this mistake you gonna do? You will tell, sir, I will find out the potential difference over here. Before that, if I wish to figure out the resistance, what is the value for R2? You're gonna tell me, sir, it is 10. What is the value for V? I don't have. All right. Over here, if I am to find out what is the value for R3, you're gonna tell me, sir, it is 15. What is the value for V? I don't have as well. So what is your task here? First of all, understand the task. The task is to find out the potential difference before you find out the current. The root question is to find out current, but when you are trying to find out the current, you are clearly seeing that potential difference is not given. Potential difference is not given. You have to calculate it. Now, how are we gonna calculate it? You will tell, sir, the ultra legend case which I was telling you. All right. So you're gonna tell me, sir, V is equals with I into R, right? So you will take I1, you will take 1 into 5. Your answer is 5 volt. Sir, my answer is 5 volt here. So here I will put 5, here I will put 5, and I will solve the answer. How many of you think like that? If you are thinking like that, a background music will come. Moe, moe. Understanding? You're gone. That is not the correct way of solving. All right. What is the correct way of solving, guys? See properly. See properly. Understand the format first of all. Understand the format first of all. The format is like this, guys. You are looking for potential difference, which you don't have in this circuit, and both resistors are parallel. All right. All right. So now let me start with the first part. How to do? Step number 1. See, I am in the approach of finding out potential difference before I find out current. All right. Your first approach. See properly. You are gonna find out the total resistance of 10 and 15. So you're gonna tell me, sir, here are P. I'm not writing the step. You guys are legends now. You know how to write the steps, right? Here given using formula, right? Mandatory in CBSE, guys. Okay. So I'm directly solving. No time. We need to slay lots of question today. All right. So RP is equals with, you're gonna tell me what is that? R2 and R3. So 1 by R2, right? Plus 1 by R3. Step number 1. In order to find out the potential difference, I'm finding out the total of this. So you're gonna tell me, sir, it is 1 by 10 plus 1 by 15. What is the LCM? You're gonna tell me, sir, it is 30. So 1 by RP will be equals with 30, right? 30. 10, how many times I will multiply? You're gonna tell me, sir, multiply with 3 times. Okay, 10 3 times is 30. You have a plus. 15 2 times is 30. I guess this much mathematics everybody knows. All right. Next step, what you will do? You will get 5 divided by how much? 30. Reciprocal it. RP will be equals with how much? 30 divided by 5. What's your answer? 6 ohm. Guys, just now I figured out the total of all the resistors here. These 2 resistors. What is the total of this? You're gonna tell me, sir, you are getting 6 ohm. Sir, you are getting 6 ohm. I will try to redraw it once again. Check it out very properly. So I am keeping the original source as it is. This resistor. How much is that? 5 ohm. What is the current flowing over here? You're gonna tell me, sir, 1 ampere. All right. Continue solving. Just now I solved. Which one I solved? 10 and 15. What answer I got? You're gonna tell me, sir, 6. So here I will fix 6. Now the question is, what will be the current in 6 ohm resistor? I want to see in the comment box. I want to see in my comment box. What should be the current in 6 ohm resistor? Fast. Then only 1 ampere. Atmana Sujit. Shreyas, very good. Adnan, very good. Well done, brother. That's my brother, guys. All right. You got 1 over here. So therefore, total PD, potential difference, right, What's the formula? You're going to tell me V is equals with IR, right? What is the current over here? What is the current over here? You're going to tell me 1 into, what is this total resistance? RP, how much is that? 6. What's your answer? You're going to tell me 6 volt. That's it, guys. That's it, guys. You will take 6 over here. That's it, guys. You will take 6 over here, right? You will take 6 over here and you will solve it. Now you'll ask me, sir, how you are taking both the cases 6? Very simple to understand. In parallel, potential difference remains same. So this is the 6 volt. You're going to fix over 6 volt. What is your answer over here? You will tell, sir, 0.6 ampere. So it was 1 ampere. From 1 ampere, how much you got over here? You're going to tell me 0.6. Now I ask you, what should be this answer? You will tell me, sir, here from 1 ampere, if I get 0.6, definitely if I do the sum, you're going to tell me 0.4 ampere, right? You guys are getting me, yes or no? Yes or no? You guys are getting me, yes or no? I should see some yes over here. So the concept is very, all right, Samir, the concept is very clear to understand how to do. See, guys, I was figuring out current. Now get this part of the question. See, the question don't have potential difference. If the question does not have potential difference, what should be your approach? Your approach is to first of all find out the total resistance. You did it, right? Assume that the result which you got is in series. Assume that the result which you got, it is in series. Once you did the assumption, after that you took that the total current should be 1. When you multiplied both, you got your total potential difference. When you fix over here to get the answer. See the verification whether you did correct or not. See the verification whether you did correct or not. Guys, it is 1 ampere, so it should divide, right? When it divide, the sum of both should be 1 ampere as well. So 0.6, 0.4. How much is that? 1 ampere. All right, everyone, please get me in a note how to calculate. This is not about this particular question. Get this clear. This is not about this particular question. Question might be in any format, but if there is no potential difference given and they're asking you current, this is the step. All right. So I guess we did it real good. Let me go with the next question on the board, guys. I want you guys to solve it. The first part will be very, very easy, but in this case, I want you guys to get the second part of the question. Do only the second part. I need to see the answer in the chat box. The second part, not of doing A and B. I will do it personally. So current flowing through 4 ohm. What is the current in 4 ohm? I want you guys to answer that. All right. Current in 4 ohm. I want you guys to answer that. Current in 4 ohm. Current in 4 ohm. Yeah, Karthik Rathor. Thank you. All right. All right. Current in 4 ohm. Current in 4 ohm. All right. Here you go. Many people are murdering. It's a cold-blooded murder, guys. Many people are telling me 2 ampere, 2 ampere, 2 ampere. It is a clean case of cold-blooded murder, guys. All right. It is a clean case of cold-blooded murder. I gotta help you out how to get this. See properly. Now, what is that cold-blooded murder? All right, see properly. See. So you're gonna tell me here like, okay, I will take formula I is equals to V divided by R, right? So what is the value for V? So you're gonna tell me 8, right? What is the value for R? You're gonna tell me, sir, 4. That's how you did, and you figure out 2 ampere, right? Right? All 2 ampere, whoever got 2 ampere, you have did this. You have did this. Once again, paper will do more. Understanding? That's not the way how you solve. Before you solve such question, you need to be very careful and understand what is the question exactly it is. Guys, see properly. This is a wrong approach. First of all, is this resistor is in series? You're gonna tell yes, sir, it is in series. And in series, potential difference is never same. Potential difference is never same. Then how come in this planet you have taken this 8 volt, fix it over here, and you solved? This is a murder, right, guys? So you cannot take 8 volt over here and so why once again? Sir, it is in series. Potential difference will never remain same. All right, everyone. Then what shall I do? What shall I do? You gonna tell me, sir, I know a concept. What is that concept? In series, total current in the circuit remains same. That is the concept, guys. What I'm wording just now. Get my word very properly. In series, total current remains same. So if they're asking a current in a particular resistor, understand the format. If they're asking current in a particular resistor which is in series, okay, they're trying to make you fool. So you should know that you guys are smart. Don't be fool. In this case, they're trying to manipulate. So what you're gonna do? You will find out the total current. To find out total current, what is your requirement? Total resistance and total potential difference. That's the correct way. I will solve it. Keep saying, guys. For the first part, right? Effective resistance of 2 8 ohm resistor. You're gonna tell me 1 by Rp will be equals with 1 by, let it be R, let it be R1, let it be R2, let it be R3. All right. Now I'll continue solving quick. Okay. 1 by R2 plus 1 by R3. This will be equals with 1 by 8 plus 1 by 8. When you solve, of course, therefore Rp will be equals with how many ohm? 4 ohm. I trust you guys. The result of both will be 4 ohm. Guys, this is 4 ohm. This is another 4 ohm. What gonna be the total? What gonna be the total? What gonna be the total resistance? Total resistance. You gonna tell me, sir, here total resistance Rs will be equals with R1 plus this Rp plus this Rp. R1 plus Rp, how much is that? You're gonna tell me, sir, 4 ohm plus another 4 ohm. What is my answer? 8 ohm. Now find the B part where you were murdering it. Get the B part clearly. Get the B part clearly. You will tell, sir, I will make it I is equals with V divided by R. What is the total V I have? Total V is 8. What is the total resistance is in series, right? It is another 8. What is your answer? 1 ampere. Guys, this is the answer. This is the answer, everyone. This is the answer, everyone. This is the answer. How much is that? You're gonna tell me, sir, it is 1 ampere. Am I clear? You guys are getting me. All right. Now, potential difference. Rest will be easy. Rest I'm leaving for you. Right? So current you already have over here. How much is that? 1 ampere. Right? Potential difference. V is equals with IR. Easy. All right. Power dissipated in 4 ohm. You use any formula. P is equals with I square R. You will get the answer. All right. So I guess I made this part very clear. The only complicated part will be how to find out 1. All right. Am I clear? You guys are understanding. I will go ahead with next question then. All right. All right. Here you go with the next one on the board. Write an experiment to show current carrying conductor when placed in a uniform magnetic field experience a force. So guys, intercept the question. Current carrying conductor is placed. Current carrying conductor is placed in a uniform magnetic field. Experience a force. Current carrying conductor placed in a uniform magnetic field. Current carrying conductor placed in a uniform magnetic field experience a force. Guys, do you remember this? Do you remember this? Do you remember this? Of course, yes, you did. Like this is an Andromeda-Ampere experiment to show force on a current carrying conductor. What you have to do in this case is very clear. I have to write the entire activity and to see what happens to the field when I reverse the direction of current and reverse the direction of magnetic field. We're gonna see everything, right? People are writing horseshoe magnet. Perfectly all right. Yes, guys, that horseshoe magnet experiment we're talking about, right? So you need to bring a current carrying aluminum rod and a horseshoe magnet in the vicinity. The meaning of vicinity is closer. When it happens, then there will be a force generated. Unavoidable consequence, guys. If I start running outside, my body will be sweating. I don't even hold in it. Similarly, if you bring current carrying conductor closer to the magnetic field in the vicinity, all right, you see the force is generated. All right, guys. Okay then. So let me see experiment to observe the force on a current carrying conductor. All right. There you have a magnet on the board, right? What type of magnet? You're going to tell, sir, it's a horseshoe magnet. Now this horseshoe magnet, I need to hold it in a stand, and what I will do next, guys, I will take a current carrying aluminum rod, right? So everybody are familiar with this. I will take a current carrying aluminum rod. What I will do next, I will name it B and A, and I will suspend it in the stand with the help of some wires. Visible? Visible? All right, guys. So next, there you have. All right, I suspended and connected. This is plus, this is minus. Next thing what I'm gonna do, I will switch it on. Once I switch it on, the current will start flowing in this wire. It will start flowing from this and it will come to B, and then it will come to A. There you have, it will come to B, there you go at the end. It comes to the negative terminal back. All right, guys. Now understand here. Now understand here. Guys, whenever you are bringing current carrying conductor, it is closer to it, and you are putting it in a vicinity of a magnetic field. All right, so you have suspended the rod in such a way, the horseshoe magnet lie in between, so the magnetic field will going upward. So if I check this direction, current is going this side and magnetic field is going this side. Magnetic field is denoted by B. So current and magnetic field in what part? You're gonna tell me 90 degree. Check this point very properly, 90 degree. All right, direction of what? Direction of current and direction of magnetic field. How many degree? 90 degree on the board. What happens then, guys? You're gonna tell me, sir, this aluminum rod will experience a force. The aluminum rod is hanging like that, it will start displacing. The aluminum rod will start displacing. I won't explain so much. I know you guys know about it. If you don't know, just check it out in a quick and later you repeatedly see it. If I keep on explaining so much, I might not slay the all questions we have today. All right. So clearly, current carrying conductor placed in a magnetic field, what will happen? It will show a displacement. The displacement of the rod suggests that there is a force generated. There is a force generated. I will ask you question number 1. Why does the force got generated? On the board, I need an answer. Why does the force generated? Why do the force generated? Why do the force generated? I need an answer on the chat box, please. Why does the force generated? Please. Why does the force generated? Okay, I want you guys to, yes, I want you guys to interact with me. All right. Why does the force is generated? You're gonna tell me very clear cut that the force is generated due to interaction of two magnetic field. The force is generated due to interaction of two magnetic field. Which are the two magnetic field over here? You're gonna tell me, sir, first magnetic field is the magnetic field produced by the horseshoe magnet. By the magnetic field produced by the horseshoe magnet. Horseshoe magnet will definitely produce a magnetic field. So this is the magnetic field number 1. Which is the magnetic field number 2? You're gonna tell me, sir, this is the magnetic field number 2. That is the magnetic field produced by the current carrying aluminum rod. That was our concept, right? So these two fields will interact with each other and it will start generating magnetic. See guys, if I give you two magnets in your hand, what you will do? You will start chasing it, right? If I give you right now, you will. Everybody have chased magnetic field in with two magnets in our life. What happens when I start bringing it? Either it will attract or repel. Let me take a case of repulsion. When you bring it closer, what happens? It will go away, right? How it is going away? With a force. How many magnetic field? Two magnetic field. This is the concept. This is exactly the concept, guys. How many magnetic field? Two magnetic field. Number 1, magnetic field number 2. When it happens, what it will generate? You're gonna tell me, sir, it will generate a force. All right. There you go in the board. Important. Very, very important. The force is due to two magnetic field due to horseshoe magnet, magnetic field due to current carrying aluminum rod. I guess I am making sense and you guys are understanding me step by step. All right, guys. What is the next part? Next part I have is the direction. If you remember in the question, they're asking what happens if I change the direction of current? What happens if I change the magnetic field direction? See guys, if I change the direction of current, say suppose the current is B to A, if I change the terminal of the battery, current will be A to B. If it happens, then what gonna happen? You will tell me that, sir, in this case, the displacement in the previous case, let's say it is towards left, the displacement will change towards right. Guys, if you change the direction of current, the force displacement will be, the displacement will be changing. That means the direction of force will be changing. So the direction of force depends on what factor? You're gonna tell me it depends on direction of current. In simple word, if you change the direction of current, how you will change? By changing the terminal of the battery. What happens then? The force will change its direction. All right, guys. Next one. What happens if I flip this magnet? Like I took the North Pole upside, South Pole downside. What will it happen? You're gonna tell me that in this case, once again, the road which was towards right will turn towards left. All right, guys. I guess you guys are very familiar with this question. So there you have the direction of force depend on direction of the current and direction of the magnetic field. The displacement of the road will be changing, all right, depending upon the direction of current and direction of the magnetic field. Am I okay? You guys are getting me. You guys are getting me. All right, guys. Let me start seeing some questions again based on this. Guys, here you know, the force is generated is towards left side, towards right side. And which rule is used to figure out the force? You're gonna tell me, sir, Fleming's left hand rule. Fleming's left hand rule, right? Fleming's left hand rule. If you remember how to remember this, just write FBI. Just write FBI, right? On your finger. Don't take it in school though. So you have FBI, right? Federal Bureau of Investigation, correct? If you remember this, you will definitely get that the thumb shows the direction of force, right? For first finger or the four fingers, the direction of magnetic field, and middle finger shows the direction of current, right? So it has two line. It has two line how to define this, guys. Definitions matter. How to define this? See the first line how to define. You're gonna tell me stretch the thumb, the forefinger, and the middle finger of the left hand in such a way that they are perpendicular to each other. Opening line. You need to stretch in such a way that they are perpendicular with each other. Why perpendicular? You will get shortly. But anyway, those who know, they know that, guys, in this case, the force will be maximum, right? Okay. Here, the forefinger is in the direction of magnetic field, middle finger is in the direction of current, then thumb shows the direction of the force on the conductor. Guys, you need to be very careful when you write. Many people will be writing it like that, which is wrong, okay? Wrong way of defining the definition. First of all, you will tell they are perpendicular with each other. Of course, I'm getting it. That makes very clear sense. But after that, you will write it in a row. Like thumb shows the direction of force, first finger shows the direction of, don't write it in a row like that. First of all, you go ahead with forefinger, middle finger. At the end, you tell that then, right? There you go. You see this part. Then the thumb shows the direction. That's the correct way of defining. That is the correct way of defining what? The magnetic, the way of defining the Fleming's left hand rule. All right, guys, you guys are getting me. That's very, very clear. All right. How do we think the displacement of road AB will be affected? How do you think the displacement of road AB will be affected? When the current in the road AB is increased, a stronger horseshoe magnet is used and length of the road AB is increased. All right. So they're asking us in this figure, what happens if I increase the magnetic field? Very clearly, if I increase the magnetic field, what will happen? The displacement will increase, right? Common sense. If I increase the current, what happens? The displacement will increase. If I increase the length, the displacement will increase. That meaning in all three cases, get the question very properly. What happens to the displacement if you increase the current, stronger horseshoe magnet and length? So once again here, if I increase the magnetic field, displacement will increase. If I increase the current, displacement will increase. If I increase the length, displacement gonna be increasing as well. Why it is so? Shortly we're gonna see a formula. Right now you carry on that all in these three cases, I wrote it very beautifully for you. In all these three cases, the force will be increasing. Am I clear to you people? You guys are getting me right. So how about the last questions of this series? Let's see the last question. They're asking you, when is this force experience on a current carrying conductor is maximum? When is this force on a current carrying conductor is maximum, and where is this force in a current carrying conductor will be minimum? Okay, when it will be maximum, when it will be minimum. All right, let me start. It's gonna be maximum when the field direction, you have seen a case of 90 degree. I want you guys to remember, if you remember that case. So if this is the magnetic field and if this is the current in that case, what is the field over here? Angle over here between them. You're gonna tell me, sir, it is 90 degree. Guys, we know this formula, right? Magnetic field, the force on a current carrying depend upon the magnetic field. If you increase the magnetic field, force will increase. If you increase the current, force will increase. If you increase the length, force will increase. Apart from this, it's also depending on the angle between both. Angle between what? Angle between the magnetic field direction and the direction of current. All right. What happens when it is 90 degree? You're gonna tell me sine 90 degree has 1, there's a greater value. So the value will be VIL, which is the maximum, All right, what happens when the case of minimum? So guys, we have two cases for minimum. What is the two cases? First is parallel, second is anti-parallel. I will show you what happens in the case of parallel direction between both. So this is the parallel direction. What is the angle between them? You're gonna tell me, sir, 0 degree. What happens if it is anti-parallel? This is the current magnetic field. What is the angle? You're going to tell me, sir, 80 degree. So when this angle is 0 degree and 80 degree, and I'm going to put it in the formula, what happens, you see, for the case of 0 degree, right? So sine 0 degree will be 0. See this properly. At the end, I have to multiply with angle. Sine 0 degree will be 0. What is your answer? You're going to tell me 0 over here. Next case, sine 180 degree is once again 0. Right? The value of sine 180 degree, once again 0. Once again, your resulting answer is 0. Are you guys are getting me? I am not seeing the chat box since I am so much on hurry in to solve all the question. Can you write some yeses on the chat box, guys? Can you write some yes on the chat box? Samir is writing yes. All right. Raghavan is writing yes. Safin, all right, everybody. That will really help me to go ahead with the session. Thank you so much for being here. Perfectly all right. And I am loving it, honestly. I am loving it, honestly. I am loving it, honestly. So many times, I am loving it perfectly. All right, you have this question on the board. Okay, current carrying conductor, magnetic field produced around a straight current carrying conductor. Get the question properly. Magnetic field, I am highlighting the key of the question only. So magnetic field in a straight current carrying conductor. You have to draw it. Then they are telling that how you will change the strength of the magnetic field. Okay, and what happens when the magnetic field associate with the conductor if its current increases. So there are questions based on this. We're gonna see all the concept of current carrying straight conductor. Later when you see this question, you gonna really answer this question well. All right. Here you go, magnetic field for a straight current carrying conductor. All right. So you know, I'm just giving a site such that you can see this very properly. You have a cardboard. What you will do with this cardboard? You're gonna tell me, sir, make a hole. So I will make a hole and insert a thick copper wire. I'm inserting a thick copper wire, but there is a condition. In such a way, the cardboard should not slide up and down. The cardboard should not slide up and down. Perfectly all right. After that, you will connect with a rheostat. If you remember rheostat, right? You're going to connect with a rheostat. There you go, an ammeter, battery, and a key. You can take 12-ball battery for this case. All right. What are you going to do next? You're going to take some iron filings inside a salt sprinkler and you will sprinkle it over here. You're going to take iron filing on a salt sprinkler and you're going to sprinkle it over here. And after that, you're going to gently tap it. When you do so, you will see the alignment of the iron filing, which is representing the magnetic field of this straight current carrying conductor. There you go, you have a rheostat. There you go, you have an ammeter, a battery, and a plug key, right? Sprinkle some iron filing, and here you gently tap it, and there you go, you have a pattern. Guys, this pattern, you're gonna tell me, sir, what type of pattern is this? This is concentric circle representing the magnetic field in a straight current carrying conductor. Guys, it's very easy to answer these activities. Make sure your diagram, you should draw the diagram. Many legends will be drawing it like this. Okay, I really mean it. Like I have seen in my paper, the moment I see this type of diagram, I feel like I got cancer in my eyes. Understanding? So you can't draw like that, guys. You can't draw like that. Make sure you need to replicate the same type of diagram which you have in the book and in the board right now. All right, magnetic field is, now what I'm going to do, I will take a point P over here. What I will do, I will take a point P over here. What I will put, I will put a compass on that particular point. And what I will do, I will increase the current. What will happen? I am answering you one important question, and help me out with this. What happens if I increase the current? If I increase the current to the deflection of this compass, what will happen to the deflection of the compass? What will happen to the deflection of the compass? First, deflection of the compass. Right, all right, I am getting answer. They're asking more. Now next question I am asking, what does the more deflection in the compass indicate? What does this more deflection of the compass indicate? Satvik, all right, perfect. More deflection, what increases? Magnetic field, perfect. What increases? You're gonna tell me, sir, magnetic field will increase. That meaning if I increase the current, deflection will increase. Increasing deflection indicates that the magnetic field associated with the conductor will also increase, right? Perfect. Now let's say I'm moving this compass from point P to point Q by keeping the current constant. Guys, in this case, I'm keeping the current constant. Whatever I'm telling you should visualize on your brain. Don't be a thinker who just think. You need to visualize the thing. What I'm doing, I'm keeping the current constant. And I'm pushing this compass which is in point P to where? You're gonna tell, sir, point P to point Q. Just I pushes the compass from point P to point Q, and what I did over here, I kept the current constant. Tell me what will happen to the deflection. I am on the chat. Tell me what happened to the deflection. Less deflection, perfect. I want you guys to stick what I am asking. Don't start fighting in the chat box, guys. Calm down, please. All right. I want you guys to answer right. Reduces, perfect, everybody. Perfect, everybody. All right, reduces. So are you telling that if I increase the distance, then magnetic field will decrease? So clearly, if I increase the current, that meaning magnetic field produced in a straight current carrying conductor should be directly proportional to the current. Magnetic field is inversely proportional to the distance. All right, write some yes on the chat box. I should see yes, guys, on the chat box. All right. It is little bit of delay. I can wait for that. Till then I can display. Perfect, lots of yeses are coming. Gaming Studio, Samir, all right, that's really good. Perfectly all right. This is physics class, not chemistry. All right. Now magnetic field is directly proportional to the magnitude of current. What happens here? If you increase the current, magnetic field will increase. All right, magnitude of current, and what is next? Inversely proportional to the distance from the point of conductor. In this case, we have seen that compass I moved from P point to Q point. Perfectly all right, Vanessa, I love this comment. All right, thank you. And we'll go with the next one. Draw a circular loop showing the pattern of magnetic field produced in it. Explain the pattern. Please enjoy the session. Lots of hard work, guys, making the PowerPoints and all right, so please enjoy the session. Keep on seeing. Don't get bored on the other side. If you are, you can do this once. All right, that is fine to me, no problem. All right, but don't get bored. All right, guys, over here. Circular loop. I'll try to keep this session full energetic till 1.5 hours. All right, circular loop, guys. There you go, the circular loop. You have never seen this, right? So if I take this one as positive terminal, if I take this as negative terminal, what happens? In this case, the current goes up. In this case, the current goes up, right, in upward direction. And in this case, the current will be coming in downward direction. All right, what I gonna do next? I will apply the rule in order to finding out the magnetic field direction. See, this is really easy how you draw this, okay? First of all, you have made the loop, number one. Then you have made it plus and minus. In this case, current is going upward. Which rule is used to determine those magnetic field? Of course, it is in the circle, right? How you will determine it? You're gonna tell me, sir, I will apply the rule. Thumbs up. Current is going. See, I'm wrapping it exactly with the arrow direction. Understanding? I am exactly wrapping it. There you go. If I play it, things will be much more fine to figure out here. Thumbs down, and there you go. Visible, right? Right? Over here, thumbs up. Okay, all right. So in every segment of the wire, you can figure out magnetic field with the help of rule. Which rule? Right hand thumb rule. All right, guys, you use right hand thumb rule in order to figure out the direction of the magnetic field. What are you gonna do next? Next you will see it very properly, and you see that as we move towards the center, get this point very clear, okay? As we go, move towards the center, the arc becomes bigger. You see, this is the arc of, this is the arc. Right now, this is the arc. This is a complete circle. Right now, this is the arc. This is a complete circle. Arc was this length, but as we go ahead and move in the center, the arc start becoming bigger. Get my point very properly. This is the arc of the circle. As we go back in the center, the arc will start becoming bigger. This big, this big, this big. Right now, it is big. In the point when you reach in the center, this is important. In the part when you reach in the center, the magnetic field line appears to be in straight line, not straight line, appears to be. Why it is appearing to be in straight line? You gonna tell me, sir, as I move towards the center, the arc becomes bigger and bigger. And at the time when I reach to the center, what happens? You're gonna tell me the arc appear as a straight line. Perfect, perfect. So magnetic field is in the form of concentric circle. These 2 points and the diagram is important. I know how you will do it. First of all, concentric circle. Next, at the center it appears as in straight lines. Understanding? Which rule you use to determine? You're going to tell me I use, sir, right hand thumb rule. So these 3 keys are important. Do this key and explain it in beautifully. When a straight wire is bent in the form of loop, pass the current in such a way it looks like anti-clockwise direction. Apply the rule to find out the magnetic field line as shown in figure. You have to support your answer with the help of figure. Everything is very plainly written in book, and 3 points should be very much clear, right? You is in concentric circle. We use thumb rule, and at the center it appears as straight line. Help me out, did you got, guys? Help me out, did you got, guys? Help me out, did you got this? All right. Magnitude we're gonna talk about, Samir. We will talk in this part. All right. Now let me discuss the same loop. Let me discuss the same loop. Okay. As an activity, write an activity. All right. With the help of a diagram, we're gonna check it once again properly. Guys, over here, you took a cardboard, make 2 holes, right? There you go. You made. After that, you're gonna insert a. This is loop, not coil. I will ask you the difference. I will tell you the difference between loop and coil also. Keep seeing. So it got inserted like that, and there you go. It comes out, right? After that, you will complete the circuit, right? What you will do, you will start seeing the direction positive to the negative, right? This is the direction of the what current, positive terminal to the negative terminal. Okay. Then what you will do, same thing. You will sprinkle lots of iron filings over here, right? Gently tap it. Right? When you do so, what will happen in the P point and the Q point? You're gonna tell me, sir, there is a concentric circle. There is a concentric circle in the center. Okay, we're gonna see the direction with the help of thumb rule. There you go, the direction. You can keep on seeing it later, right? There is a direction visible. We have seen already. And in the center, it will appear as straight line. It will appear as straight line. So you have to answer exactly the how you have drawn the diagram. What happens when you sprinkle, what happens when you tap. You will tell in the circumference of the wire, it's going to be concentric circle. As it comes in the center, it appears as straight line. Same thing what we have learned in the previous case. All right. So this is loop. Done. You have in your book coil, right? Magnetic field within coil. Guys, it's the same diagram, right? What's the difference between loop and a coil? Loop will be expected as in single wire, whereas coil will be lots of wire coil like that. Okay, you're gonna have the same magnetic field pattern. All right. Now, for the magnitude, Samir was asking, I have seen the comment over here. Magnitudes, guys, depend upon directly to the current if you increase the current, and it depends upon inversely to the radius. What I mean is distance, if you remember. All right, guys, very quick. All right, I can't stick up onto the same part. Okay, you have your book. This will be available in YouTube. After that, keep on seeing, keep on learning. You have time. All right. So draw a schematic diagram for the domestic circuit. It's time to learn about the domestic circuit, guys. Okay, it's time to learn about the domestic circuit. There you have. Very quick. First thing, does this drawing comes in your exam? Yes, sir. Now those who are in a like relaxing situation, sir, this diagram, okay, it comes in exam. It directly appears in the exam. Make sure to practice it once. All right. So you have this domestic circuit, and you know how many types of wire you have? 3 types, right? Live, neutral, and earth wire. Let me talk about live and neutral. Both will have a potential difference of how much? 220 volt. First of all, it enters in electric fuse. You're gonna tell me electric fuse works under Joule's law of heating, protect us from unduly high current overloading. So I am telling you that the fuse wire works under Joule's law of heating, and it protects us from what? Overloading, right? It will melt if the current is more in Joule's law of heating. It goes to electric meter that gonna measure the amount of electricity you consume in kilowatt hour. After that, you have this distribution box. From distribution box, it distributes inside our home. wherever the device, right? From distribution box, we'll see it inside our home. All right. All right, guys. Now if I keep on seeing it continuing, guys, and then it goes to the circuit. Now it's time to discuss about the circuit over here, guys. Often two type of circuits we use. Potential difference is 220. Potential difference is 220. Okay. Often you use two type of circuit. This is important. This is important. Often we use two type of circuit, right? One is of 15 ampere rating. One is of 15 ampere rating. Alright, if you see around, there are 15 ampere rating of the circuit, right? Where we use the 15 ampere rating, like air cooler, geyser, those switches of how many rating? 15. I guess all this planet of class 10 knows this. If you don't know, see it properly. Okay, so 15 ampere rating. And what is the other rating? Other rating is for 5 ampere, right? Light circuit and the power circuit, right? So here these are bulb and fans. So you have that circuit inside your home where you plug in your bulb and fan. It takes a current of how much? 5 ampere. For greater device, it takes a current of how much? 15 ampere. So inside your home there are two type of circuit. How much are those? How much are those? 15 ampere and 5 ampere. 15 ampere for bigger devices, right? And the 5 ampere for small devices. Guys, this was the key part of your domestic electric circuit. What are the key part? You're gonna tell me, sir, the diagrams, right? You have to learn it. Once again, I told it very quick in a short. Okay, short and precise, but all contents were there, right? So you have this, right? Two different type of circuit. All right, it's time to talk little bit about earth wire. Okay, I don't have a script, but it's time to talk little bit about earth wire. So earth wire is a safety measure, you know it, right? Earth wire is a safety measure. So sometime what happens if I touch a body of a metallic device, what happens is I start getting electric shock, a little amount, mild amount of electric shock I used to get. Now that electric shock is due to leakage of electricity on the machine, right? Electricity always go with the lowest path. Like if the metallic body you have, metallic body always offers the lowest path of, lowest resistance. So it will start flowing through that part, right? And it will come to the body of the machine. What I am telling, if you are not relating, so suppose this is the machine, right? Inside there is a the PVC coating of the wire might have broken. In course of time, we're using it, right? And the current got a leakage on the body. So when I touch this, I will get a small amount of electric shock. Now, in order to save me, I'm the user. In order to save me from this, who takes the prevention? You're gonna tell me, sir, the earth wire. So what does earth wire do? I won't explain in that detail. This is more than enough, right? That it takes the leakage of current in the machine into the earth, making the user safe. The process is called earthing. The process is called earthing. Very beautifully written in your NCERT textbook. Last page of domestic electric circuit about earth wire. Do read it. Their overloading and short circuiting is also there. Do read it, everyone. All right, guys. Here you have the next question on the board. The next question on the board. One of the most famous question and keep on repeating on the paper. All right. So one of a famous question, I see this current, right? So let's say the potential difference is 3 volt, right? And what they're asking what is the current in this network? What is the current in this network? So clearly what happens is, here the current will be dividing into 3 paths, right? So this is the first path, this is the second path, and this is the third path, and this is the fourth path of the current. You can see the current in the fourth, not path actually, I just marked 4 different paths over here. Now, when the current comes, it will divide in 2 different paths. This is the path number 1 and this is the path number 2. That's how it divides. Now, clearly, here the current remains same. In the 3 resistor, let it be R1, let it be R2, let it be R3. What happens in R1, R2 and R3? The current remains same. And where does the current remain same? You're going to tell me that the current is remaining same only in series. Current is remaining same only in series. Help me out. What should be the total resistance, guys? I should see in the comment box what should be the total resistance over here. You gotta tell me that the resistance in series is equals with R1 plus R2 plus R3, and everything is our 10 will be equals with how much? 30 ohm, right? Now this 30 ohm is parallel with this 10 ohm. The current is dividing, right? So this is the very casual circuit of all the 3 network over here. So this is 10, this is 10, this is 10, this is 10, right? So this 3 will be how much? 30, right? And parallel to how much? This is 30. What happens, guys? So 30 and 10. So you're gonna tell me that, sir, 1 by Rp will be equals with 1 by Rs, that is 30, plus 1 by R, how much? You're gonna tell me R4. Let it be R4. Let it be R4. let it be R4. Those who are not understanding, very clear. 1, 2, 3 are in series, so I connect it in series. Which is in parallel. R4 is in parallel, so I connect it in parallel. What should be my answer? I will keep on solving to get my answer. You're going to tell me, sir, it is 1 by 30 plus 1 by 10. And I will solve. LCM is 30 one time, right, plus 3 times. This will be 4 divided by 30, right. On the other side, I have 1 by RP, right. What I will do next, you will tell, sir, I'm going to cancel. I'm going to cancel what? 2 and 15, right. So keep continuing to solve. When you do so, therefore, RP will be equal with 15 divided by 2, that is equals to 7.5 and ohm. 7.5 ohm is your answer for the total resistance. Since they're asking the current over here, what I will do, I will put the formula I is equals to V divided by R. Okay, using then what is the value for V? You're going to tell me 3. Right? What is the value for R? 7.5. So when you solve this 30 divided by 75, your answer should be definitely 0.4 ampere. All right, 0.4 ampere. All right, 0.4 ampere. Guys, this is the question you got, and what is your answer over here? You are telling me, sir, 0.3, 0.4 ampere. Perfect. Many of an answers. This is what is something I will appreciate. Please write the answers. All right. All right. All right. All right. Then what gonna be the next? Next is to do the next circuit over here. Guys, in the next circuit, what happens, you need to divide this part, current, into different half, right? Current over here, it divides into two different parts. It divides into two different parts. Guys, this one is in series. This is also in series. Why? The current remains same. Why? The current remains same. Why? The current remains same. In this case, these two will be series as well. Why? The current remains same. So upside 2 is series, downside 2 is series. So what I'm going to do over here, you will tell, sir, mark the values as R1 and R2. Mark these values as R2 and R3 and R4. I'm marking as R1, R2, R3, R4, whatever the you want, you can mark it as usual, your wish. After that, I will start solving it 1 by R. Sorry, it is in series. First of all, I'll solve for the series. Here, series is RS is equals with R1 plus R2 will be 10 ohm plus 10 ohm. That will be equals with 20 ohm. Just now I solved these two. Just now I have added because this one and this was in series. So 10 plus 10 will be how much? You're going to tell me 20. Am I okay? You guys are understanding. All right. Solve this now. So you're going to tell me, sir, RS dash is equals with how much? R3, R4. R3 plus R4. That will be equals with another 10 ohm plus 10 ohm. All values are 10. You are getting another 20 as your answer. All right. I'm already getting the answer. That's really good. So what you're going to do next, you're going to put it in a parallel. Like 1 by RP will be equals with 1 by RS plus 1 by RS dash. That will be 1 by 20 plus 1 by 20, right? So your answer, I know you will solve it by taking LCM. So 20 and 20, half of the number will be 10 ohm, of course. All right, 10 ohm, of course. But they're asking us to get the total current. What I will do, I is equals with V divided by R using the formula. All right. What is the value for V? 3 volt is given. So 3 volt is given. Divided by 10, your answer is 0.3 SI unit is ampere. Done. All right, guys, lots of answers. That's really good. Atmana, really good. Let me tell your names. Safin, very good. Avinam, Satvik, Rahul, message related. All right, Safin Parker, very good. All right, you guys are doing it. Really good. Venika, Samir. All right, Deepak, very good. You need to study hard. All right, Abhinav. All right, Shreyas, you are here. Very good. All finally I can do numerical. Vanesha, very good. It's easy, guys. All right, that's really interesting. I am loving your all comments. So it's time to go ahead. What is a rainbow? One of the most fascinating concept, guys. What is a rainbow? You're gonna tell me rainbow is a natural spectrum form in sky. Natural spectrum form, a band of 7 colors. You see the band of 7 colors, right? Natural spectrum form in sky. Now the question is, with diagram, explain the formation of rainbow. Get me very properly. I will be very quick to explain. Keep saying. So first of all, the condition. Let me have some rain shower. It's very hot over here. So you have this rain showering and you have this sunlight. Condition for the formation of rainbow. You're gonna tell me, sir, there should be rain, there should be sun. There should be rain, there should be sun. That is the condition, right? Without these two events, you can't see it. All right, go ahead. So raindrop, Get these points very properly. This point will help you to construct your answer. And the points are very clear. First of all, condition, you have a raindrop which act as a small prism. Raindrop will be acting as a small prism. And what happens next? Sun, right? And you have a light which is going. As soon as this light encounters in the raindrop, what's gonna happen? You will tell it will slow down, guys. Light doesn't change its speeds, it slows down. There's a big part to understand this statement which I'm telling. Join us for ask your brother and sister to join class 10 and definitely help why light doesn't change its speed but it slows down. All right, guys. So you got the sunlight going and encountering the raindrop. What's gonna happen? You will tell us there will be a change in speed, right? It slows down. It slows down. The proper term, slows down. Slows down. Why? Slows down to 2.24 into 10 raised to 25 into 10 raised to power 8 meter per second from 3 into 10 raised to power 8 meter per second. What I'm telling, in air, what is the speed? 3 into 10 raised to power 8 meter per second. What is the speed in water? You're gonna tell me 2.5 into 10 raised to power 8 meter per second. Perfectly all right. Okay, so here there is a dispersion and refraction. Can you see it? First event, there is a dispersion and refraction. There is a dispersion and refraction. What happens? It will bounce back. You have an internal reflection and finally it will disperse and refract again to get the formation of rainbow. All right, guys, how to see the formation of rainbow? Once again, first of all, there should be a rain showering, right? Sun, all right, raindrop act as a small prism. You have sun, light encountering the raindrop. What happens? You're gonna tell me there will be dispersion and there will be refraction. What happens next? Reflection. What type of reflection? Internal reflection. At the end, you will see disperse again to form the formation of rainbow. Perfectly all right. You guys are getting me how the concept of formation of rainbow. I will ask you one small question. Is rainbow is round or semicircle? On the comment fast. Is rainbow is round? On the semicircle fast. Semicircle, many a semicircle, semi, guys, it is not semi. It is not semi. Study really well. Buy your own private jet. The day when you will see, the perfect day, when you will see a rainbow, fly high. All right, I want you guys to fly high, right? Buy your own private jet. Become a millionaire in future and fly high to see the rainbow when you are going in a height, right, above the horizon. Right now we are in a horizon, sea level. We are in a horizon, sea level. When you fly high above the horizon, you're gonna definitely see rainbow is round, everybody. It is circle, right? It is circle. That's your correct answer. All right, keep going. What is recombination of light? Draw a diagram. Recombination of light, draw a diagram. All right. So one of our very, very interesting part. Many of you will not learn it, not draw it, resulting in very disaster diagram you drew in your exam paper. So make sure to see it properly and learn it. All right. So there you have two prism, straight and inverted, right? You're gonna pass a white source of a light. What you will see? You will get a spectrum, right? So this spectrum is allowed to pass through another inverted prism. What happens? The white light reappears. This phenomenon is called recombination of white light, guys. Okay, the diagram is very clearly visible. This diagram has little bit of fault like this ray and this ray should be exactly parallel. So make sure to see the NCERT diagram. All right, the phenomenon you see is called the refraction, the recombination of white light. Guys, important diagram, mark it. It appears in exam paper and many of you will be ending up not solving it. All right, why do star twinkle but planet do not? So your entire life was a light, twinkle twinkle little star, but you know guys, star doesn't twinkle, it appears to be twinkle, right? Entire life was a lie. Let me start seeing it step by step. Let's see the first one. Okay, you're gonna tell me that this is the denser medium, you're gonna tell me this is the rarer medium, you're gonna tell me denser medium, you're gonna tell me rarer medium. All right, what happens then? You will draw normal in every point, correct? So when the light ray comes from a star, it should bend towards the normal because rarer to denser, it should bend towards the normal. There you go, it is bending towards the normal. All right. Now what happens due to bending towards the normal? Get this point very properly. Answers how to write I will show over here. All right. Answer what I will show over here. But first wording is star twinkle due to atmospheric refraction because of changing in the refractive index in the different layers of the air. Right. Rarer to denser, very clearly visible. Okay. So starlight while comes to the observer. Point number 1. Starlight while comes to the observer. What happens? You're gonna tell me, sir, it bends towards the normal. It bends towards the normal. So due to bending towards the normal, you will see the apparent position slightly above than the actual position. Here I go. The starlight bends towards the normal. Since it is bending towards the normal, you're gonna tell me that the apparent position, this is actual position, we never see it. Right? We're gonna see which position, apparent position. Where is the apparent position? You will tell me slightly above. Why the apparent position is above? You're gonna tell me because, sir, because the starlight while coming to the observer is bending towards the normal. All right. After that, this apparent position is not stationary. Get me another point. Apparent position is not stationary. All right. What it will do? It will fluctuate like that. Visible? It will fluctuate. What is the reason of fluctuating? You're gonna tell me, sir, due to physical condition of Earth atmosphere does not remain same. Guys, this is what the concept of star twinkling. This is part we need to write. Okay, if they ask explain how star twinkle, your answers are very clear. First of all, you are giving a reason. It twinkles because of atmospheric refraction. Second point, you're gonna tell that starlight while coming to the observer, it bends towards the normal. It bends towards the normal. Due to bending towards the normal, you see the apparent position slightly above. Moreover, the apparent position is not stationary. Why? Because the physical condition of Earth atmosphere is not same. Because of this, it will be keep on fluctuating. Now give me an idea, guys. A star is that far away. Let me see. I am seeing stars. Okay, you also see like that. So I am seeing stars that far away. How do I see stars? You're gonna tell me, sir, it's a point source of light. It's just a point. And what is happening with that point? It is keep on changing its position like that. This gives rise to the twinkling effect. Since it is fluctuating like that, sometime it will be fainter, sometime it will be brighter. Now since the fainting and brightening giving rise to this twinkling effect of the stars. Moreover, the path will be keep on changing. All right, there you go, the first part. Star twinkle due to atmospheric refraction. The atmospheric refraction occurs in a medium of gradual change in refractive index. Point number 1, which we already seen. Secondly, since the atmosphere bends the starlight towards the normal, the apparent position of the star appears slightly higher than the actual position. Bending towards the normal, this is slightly higher. Next case, this apparent position is not stationary but keep on fluctuating, right? So further the apparent position of the star is not stationary but keep on changing. Now star is a point source. It is in distance object, it's a distant object very far away, and secondly the ray of light will keep on varying when it reaches. This will give rise to twinkling effect of the star. There you go, your ending part. Star is very far away. All right, the rays coming to the star from the star keeps on varying. Okay, and this position position fluctuates, giving rise to the twinkling effect. Am I clear? You guys are getting? Tell me yes or no. I need to see some yes, guys. I need to see some yes if you are getting me. Yes, perfectly, all right. Okay. That is okay. I'm getting lots of support. Those yeses are what I want from your side. All right, such that it will keep me going with lots of energy. All right, guys. All right, perfect. Very good. Okay then, planet doesn't twinkle. Planet doesn't twinkle. Very common question in exam. I'm just picking those questions which are commonly appearing, right? So planet doesn't twinkle. Why so? Because it is very closer. So this part is very clear. Rarer to denser medium it comes, and planets are very closer, right? So since they are closer and they are good extended source of light, they can also be tell as collection of point source of light. What I told here just now. Please understand. First of all, this layer is denser and this layer will be rarer, right? So planet is nearer compared to star, and next they are collection of large source of a light, point source of a light. Why we have termed it as a collection of point source of a light? See guys, we are comparing with star. We are comparing of star. Star is a point source. So if I collect lots of star from this board, I wish I can do that. So if I collect lots of star and put it one side, it becomes a planet. If I collect lots of star and put it one, it becomes a planet. It becomes a planet. So that's why they are telling collection of large number of point sources of light. It's an extended source. Guys, 2 point On the third line, you will write why planet doesn't twinkle. Point number 1 on the board. Alright, planets are much more closer compared to the star. Point number 1, how you will write this answer? Point number 1, it is much more closer. Number 2, they therefore do not appear as a point source but appear as a collection of point source. Understanding? They are telling that the planet are collection of a point source because they are much more closer, right? And extended source of light. Now since they are closer, extended source of light, all the amount of total variation of light entering in our eye will average out to 0. The variation you have seen in the star at the end of the part, the light ray path varies that give rise to the twinkling effect, one of a point. But here those variation will be reduced. Why? Closer extended source of light. Now because of this, it will nullify the twinkling effect of star. Am I okay? You guys are understanding? These are the 3 lines that will help you out. Yes, all right. These are the 3 lines. These are the 3 lines that will 3 points that will help you out to understand why do planet does not twinkle. All right, guys. Next question, important. Next question, important. Why does the sky appears blue? I want you guys to see the principle of sky appearing. I should see in the comment the principle. Why does sky appears blue? Sky appears blue. Sky appears blue. Why does sky appears blue? All right. Scattering. Perfect. I'm getting answers. Scattering. 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 I can see some people are fighting in the comment. Moye moye kar dena. Trust me. You know me really well. All right. Scattering. Stick to the topic, guys. All right. Scattering. Perfect. Scattering. Perfect. Perfect. Scattering. All right. All right. All right. Now let me start dissecting this answer step by step. All right. There you go. So you have got this sun, you have got earth, and this is the case of no atmosphere. You have one more question. Why sky appears dark for the passenger flying in a high altitude, right? So you have this side as no atmosphere and this side as atmosphere. Sunlight will be coming this way, right? There you go. Here it will be appearing blue, but here it will remain as it is darker. Now let's say, why it is blue? You're gonna tell me, sir, due to scattering. What happens? I'll speak in word. Later on I will display you the answer. First of all, understand me very properly. We know the composition of atmosphere. You're gonna tell me that, sir, atmosphere is composed of minute particles, right? Minute particles of what? Dust, smoke, air particles, etc. Right? And it's a heterogeneous mixture. Now since it's a minute particle, a heterogeneous mixture, what happens? It's a minute particle. This is the key over here. Minute particles. You need to tell me which color will scatter mostly due to minute particle. I need to see it on the chat box. Minute particle. Minute particle. Yes guys, minute particle. Which color will scatter? Blue. Perfect. Blue will scatter, guys. Those who are telling me red, red need a bigger particle, red need bigger particle, blue color will scatter. Perfect. Blue color will scatter. So over here all the blue color will scatter. Your answer is very clear. You're gonna tell the composition of atmosphere. First of all, you will tell me that atmosphere is composed of minute particles. Atmospheres are composed of minute particles. Now those minute particles scatter mostly the blue color compared to the red end. And this scattering particle reaches to the observer. I'll be saying it like that, right? So reaches to the observer, giving rise to the bluish appearance of the sky. All right, guys, this was your answer. How about this case? You're gonna tell me in atmosphere, no atmosphere. If there is no atmosphere, there won't be scattering. There will be no particle to scatter. And if there will be no particle to scatter, though there will be light, get me this point very properly. Though there will be light, you will not see any color, so it gonna appear as dark. All right, everybody, you guys are getting me. Perfect. All right. So these 2 questions are so important, and you know it appears in your exams. All right, keep going ahead. This is your answer. Later on you will read it. Okay, it is also available in NCERT, though this is a good version of NCERT. All right, so next, What is myopia? Another question appears in exam many times. But you people make mistake in the diagram. You people make mistake in the causes. Alright? Step by step we're going to learn. Myopia. What is the far point of myopic eye? The answer was nearer to infinity. Answer was nearer to infinity. Alright. Draw a diagram for the formation of image of a myopic eye and state 2 reasons due to which eye defect may cause. How can such eye defect be rectified? Alright. So all these answers can be easily answered. If I tell myopia, we have a problem where we cannot see the far away. It is not that clear. It appears blur, right? A person suffering from myopia can see the nearby object clearly but cannot see the distant object distinctly. Alright. Many people will write the answer like this. Person can see nearby people, object but cannot see. That's not the answer. You have to interplay with 2 terms, clearly and distinctly. Clearly and distinctly. How you will interplay? We can see the nearby object clearly but cannot see distant object distinctly. Alright, but don't write it like that. We can see the nearby object clearly, cannot see distant object clearly. In English, we don't use the same term together in a particular sentence. Okay, since you are writing clearly over here, on the other end you have to write distinctly. Understanding? So clearly, distinctly. That's how your entire answer is framed. So myopia is a condition where a person can see the nearby object clearly but cannot see the distant object distinctly. I guess you guys are getting me that clear. And here you have the far point of myopic eye. I wanted to see the far point of myopic eye. What is the far point? On the chat box, please. Far point of myopic eye. On the chat box, guys. Far point of myopic eye. On the chat box, guys. On the chat box, far point of myopic eye. Alright. Alright. I guess the chat box are stopped. Okay, maybe. Alright. I keep on explaining, you guys keep on seeing me clearly. Alright. Far point of myopic eye. You gonna tell me that, sir, the far point of myopic eye will be nearer to infinity. Nearer to infinity. I am the guy who is suffering from myopia. So what gonna happen to me? If I start seeing the distant object, I am unable to see it very clearly because it is at infinity. But the portion up to where I can see is nearer to infinity. Infinity is not clear to me. If this object is clear to me, it will intersect back of retina exactly. I mean that this is not infinity for me. This is nearer to infinity. Those who are not understanding it is very clear cut to understand, guys. What is the far point of myopic eye? Not infinity. Normal eye is in far point. Infinity. Myopic eye is nearer to infinity. Keep this in your mind. Question is very common. Alright, you will lose mark there. Okay. The light rays, so far point, nearer to infinity. Let me see the diagram first and then we'll see the writing second. Alright. So it is from infinity and nearer to infinity, it is intersecting in this point. Now myopic eye, right? There you go, the problem is. Myopic eye, there you go, the problem is. Myopic eye, there you go, the problem is. What is the problem? The ray, instead of intersecting in the retina exactly, it is intersecting. Understanding? It is intersecting just nearer to, forward to retina. It is not intersecting in retina, right? So why it is happening? There you go, the cause. Elongation of eyeball. So elongation of eyeball. Next case, excessive curvature of the cornea and the lens. So there will be excessive curvature, or you can simply tell that the focal increasing, guys. These are the 2 causes why you are getting myopia. Right? It is not disease, this is a defect. What type of defect? Refractive defect. How you can correct it? You're going to tell me, sir, I will use a lens for the correction. Which lens I am wearing? You're going to tell me, sir, this lens. Which lens is this? You will help me out with, sir, this lens is a concave lens. So when I fix a concave lens, my intersection goes back to retina. So the task is very easy. Here the intersection is in front of retina, not in the retina. It is in front of retina, not in the retina. Since it is in front of retina, I am unable to see the object clearly. So my next task is to bring this intersection back to retina. To bring this intersection back to retina, what I will do? What I will do to bring this intersection back to retina, what I will do, I will use a lens. Which lens you will use? You will tell me, sir, I will use concave lens. When it happens, all right, your intersection which was in front of retina will go back to retina and the object will be very clear. Sir, why it is happening? Because of the lens. There will be small divergence. This is small divergence, right? This is small refraction restores our vision. So it is a refractive defect. I guess you guys are understanding. Very easy to understand. I'll go a bit slow if you want to. Now, power of concave is negative. Everybody knows it. All right. The next question which I am taking is, what is hypermetropia, everyone? What is hypermetropia? And all the question is similar as what we have in the myopia case. What is the near point of hypermetropia? Draw a diagram and state two reason how you will correct it. All right. So what is near point of an hypermetropia? If I ask you guys, you're gonna tell me, sir, it is how much? How much? How much? You're gonna tell me, sir, it is more than 25 centimeter, right? So this is the near point of an hypermetropic eye. So what happens when I see the object? If I see, you have seen people reading newspaper like that, right? And then they will see, what is the normal near point? Normal near point is 25 centimeter. What is the normal near point? You're gonna tell me, sir, 25 centimeter. Normal near point, 25 centimeter. Can I see it? Yes, but there are some people who can't see this. They have to do like that, right? So what is happening with that normal near point for those people? Residing away, that is greater than 25. So this is greater than 25. What happens when they try to see the 25 centimeter? You're gonna tell me, sir, the intersection will go back to the retina. Backside of retina. It is not in the retina. Once again, the problem. They cannot see the 25 centimeter. When they try to see the 25 centimeter, the intersection will go back of retina. So what is happening clearly? The focal length is increasing. The focal length is increasing and eyeball becomes small. These are the two cases. See, eyeball is becoming small and the focal length is increasing, guys. These are the two cases why people get hypermetropia, right? So what happens next? You are using which lens? You're going to tell me convex lens. Okay, and how you will correct it? By using a convex lens, what happens? See, the ray will pass through this part and what will happen? There will be small convergence. There will be small convergence. Now this small convergence will restore the vision back. So these are the writings I'm giving aside. You can see it properly. All right. All right. All right. So you guys are understanding myopia, hypermetropia, one of a very common comes in exam. I want you guys to practice what? I want you guys to practice this diagrams properly. Okay, it's gonna definitely appear. Don't lose mark. Don't lose mark for any cases. We will continue a quick revision for ray diagram, and we'll try to wind it up. All right, quick revision to the ray diagram and we'll try to complete our session. Followed, you have in chemistry to go and you have biology, chemistry by our great Sudhir sir, right, and biology by our great KD sir. All right, keep seeing. So what happens when the object is beyond C? Beyond C, all right, not beyond C, the single, beyond C, all right. So if the object is beyond C, what happens? You're going to tell me it is A and B, right? First ray will be parallel, it will reflect through focus, we know it. And the second ray, what will happen? You're going to tell me, sir, it will pass through the focus and there you go, it reflects back parallel. You know the rule, it is very clear. I'm just giving a highlight. So where is the image forming? The point of intersection. Here is where the image will be forming. So B dash and A dash. What you will comment about this image? You will tell the image is formed between C and F. So C and F, all right. The nature of the image is real because it is upside down. If I keep on going, it is inverted. So I guess you guys are getting me clear. So this is the ray diagram you have for what? Object beyond C. All right. So let's keep going. Object at C. We know object at C will be same size, right? Object at C will be same size. So where is the object at C? AB. So what type of ray goes? The first ray travels through parallel. It should come back through. There you go. All right. So you know the rules. This is the meeting point. So make sure your meeting point should be very clear. Okay. Ray diagram. Just giving you a highlight of everything. You know it appears in exam. Many people ends up with drawing there here and there. So what you will comment? So image is also at C, nature of the image real, okay, and it is inverted and same size. Perfectly all right. Okay. So object between F and C, object between F and C, object between F and C. There you go. Image will be B on C, right? Image will be B on C. So this is the first ray, second ray. I will be very quick to show you guys. All right. The only motto of showing you guys is to practice. You have to practice this. Many people will not do. I know. Exam, right? Practice. So there you have. Right. Comment over here. You will tell me, sir, B on C. Okay. Nature of the image is real, inverted, and magnified. Real, inverted, and magnified. Perfect. Keep on going, then you will see the object will be at F. If the object is at F, image will be at infinity. Object is at F, image will be at infinity. The case of vehicle headlight, right? Okay, there you have first ray. First ray, all right. Second ray towards center of curvature, it will retrace the path, and you will see there will be no intersection. So image is formed at infinity. All right. Nature of image is real, inverted, and highly magnified. So you guys are getting me, and I am making sense of how these ray diagrams are formed. So one of a specific point about the ray diagram, you should know the first ray is always parallel. First ray is always parallel. What is the second ray has a problem? You're going to tell me the second ray is changing its path, which you need to see it. All right. In this case, it's going to hit to the pole as well. All right. Which you have in a NCERT text, NCERT textbook. Both goes good. All right. Parallel will pass through focus. There you go. Okay, no intersection in front, so intersection will be where? You're gonna tell me, sir, intersection will be behind. No intersection in front, you're gonna tell me where is the intersection? You're gonna tell me behind. All right, where is the image form? In this point, there you go. A dash and B dash is the image. Make sure ray diagram, very important. All right, comment upon it. You're gonna tell me image is behind the mirror. All right, what gonna be the next? Virtual, erect, and magnified. Similarly, you have image for convex mirror. There you have. Right, related guys, at infinity, diverges, appears to meet at focus, and there you have the image form. At focus, virtual, erect, highly diminished. At focus, virtual, erect, and highly diminished. All right. So can object between infinity is placed in a convex mirror? So there you go. Between infinity and pole of a convex mirror. Between infinity and pole of an infinity and pole of a convex mirror. There you go. I am done with the part. All right, guys, these are the part which we have. We don't have time. It's already 4:30, right? So there will be another session followed by chemistry and biology. Stay tuned. I will see you shortly.
Good morning.
Good morning. What's all this? Your results. Congratulations to all. I'm confident you'll all achieve your goals. So, young man, what are your aspirations?
I want to do robotics, ideally from the Bust Institute in the US.
And you, young lady?
Sir, I love kids and I would love to learn pediatrics. I feel Boston is the best place for that.
Sumit, what about you?
Back home to India for medicine.
Good. I'm sure you'll all achieve your aspirations, be it in India or anywhere. Keep in mind, your first challenge is the entrance, whether it's IIT,
J.
SAT, or NEET. You have to learn from the masters. Brilliant Qatar is the passport to your success.
We undertake coaching for regular and repeat batches and tuition for board examinations. Brilliant Education Centre, Doha, Qatar.
Yes. Yeah. Good evening, guys. Welcome back to live session from the group of institutions. So here we are going to start the marathon for the chemistry. So already your presentation is being done, your questions preparation, everything is being done. At the last minute, what all you are going to revise, what are the points you are going to stress, regarding that we are going to see very shortly and very briefly and very briskly. Okay, without wasting our time, let us run into the topic. The first question is before you. See here, write the balanced chemical equations for the following chemical reactions. So what are the various chemical reactions? So balancing question is one which is coming definitely in your board exam. So now, what is the first question? Reaction between hydrogen and chlorine. H2 combines with Cl2 to form HCl. So this reaction is the first reaction. This we need to balance. Last time also we have discussed how do we balance the equations. So first we need to give preference for the metals, then give preference for the non-metals. So here, as we don't have metals, let us go for the non-metals. Any one is fine. So hydrogen, here we have 2 and here we have only 1. So multiplied by 2. So 2 HCl. Automatically the chlorine also gets balanced. So reaction is balanced. So second equation, we have lead and copper chloride. Remember children, copper chloride. Copper has got 2 valencies, copper 1, copper 2. Whenever such a kind of doubt appears for you, if the charge is not mentioned, make sure that you take 2 as a default for grade 10. So here copper 2, that means the formula will be, if the copper charge is considered as 2, the chloride valency is 1 and we crisscross, we get CuCl2. So as a result we are having, so CuCl2 when treated with lead, what will be happening here? We get lead chloride. So it will be PbCl2 plus Cu. So if you observe, this reaction is already balanced. This reaction is already balanced. The only point here difficulty is which ion has to be considered, because lead will be having 2 as a charge. So to compensate that one, what should be the charge of copper? So it should be, charge should be taken as a 2 considered, 2 plus. So it will form CuCl2 plus Pb. Got the point clear? And the third one is given for you as zinc oxide. Zinc oxide plus carbon gives rise to zinc plus carbon monoxide. So can I get the answers with you children? Right? So please message your answers in the chat box. Right. So here ZnO plus carbon gives rise to Zn plus carbon monoxide. This equation is also balanced. So make sure that you balance the equations properly. And there is one more equation which I wanted to write apart from this is combustion of pentane. In one of the board examinations around 4 to 5 years back, they have given that combustion of pentane equation. C5H10 plus O2 gives rise to CO2 plus H2O. If you observe this equation, we will be getting a fractional coefficient. So if you start balancing, so here we have 5 carbons, so here we will be adding 5 carbons, right? So when you take hydrogens, there are 10 hydrogens, here we have 2, so it will be 5 into 2, 10 hydrogens. Now when you come to the case of oxygen, here we have 2 oxygens, but here we have 5 into 2, listen carefully children, 5 into 2, 10, plus 5, 15 oxygens are there. So 15 oxygens should be balanced by 2 oxygens on the left. So what did we do here? When we make it into fractional coefficients, it will be coming as 15 by 2. So here 2 should be multiplied by what to get 15? So here the coefficient will be 15 by 2. So 15 by 2 oxygen. And when we multiply the whole equation by 2, the final equation, I am writing it here. See children. So it will be multiplied by 2 means 2C5H10 plus 15O2 gives rise to 2 multiplied by 5, 10 CO2 plus 2 multiplied by 5, 10 H2O. So this way we have to solve the equation. Am I clear to all of you? So one equation, if it is having a fractional coefficient, the best method is multiply with the denominator and then balance it very comfortably. So this way we have to go for balancing of equations. I hope I am clear, right? Next question. Let us go for the next question. The next question is one more activity based question. 1 gram of copper powder was taken in a china dish and heated. Right. So what change takes place on heating when hydrogen gas is passed over this heated substance? So my dear children, kindly make your answer very short and sweet, right? Yes, I'm getting the answer. Safin is answering, right? So Praveena is answering, right? Very good. So 1 gram of copper powder. So Cu is getting heated. So we have seen last time also, when copper gets heated, it reacts with oxygen to form black colored copper oxide. Remember children, it will be black colored copper oxide, right? And then what is the next step you see? When hydrogen gas is passed over this, when hydrogen gas, CuO, when passed with hydrogen gas, it will be giving you back copper plus H2O. This is the equation. Now what is the question here? Observe carefully the question. Give the chemical equation of reaction. Already we have given it. The name and the color of product formed in each case. The name, this is copper oxide. Here we have copper. And the color change in each case. Here the black colored copper oxide is giving you brown residue of copper. Remember children, brown residue of copper is being formed. Right, very good. Yes. Come on, join, come on, quick, right. Very good. So that is the next question. Let us go for the next question. Question number 3. See here there is a small tricky part. Let me find out what is compound A. Let me see the chat box who will be able to give the answer. A compound A is used in manufacture of cement. Which is that compound used in cement? Whenever cement is being coming, immediately our mind goes directly to gypsum and POP. But remember children, every day is not Sunday. So every substance which is involved in the cement will not be calcium sulfate or POP. Listen to the answer very carefully. A compound A is used in manufacture of cement. When dissolved in water, it evolves a large amount of heat and forms compound B. For your information, calcium oxide is also used in cement industry. Calcium oxide is also used in cement industry. So the question lays with calcium oxide. Very good children, very good Pravina. So calcium oxide. So here compound A is calcium oxide. And then when dissolved in water, CaO when dissolved in water forms CaOH twice along with heat. Identify A and B. So we identified A is calcium oxide and B is calcium hydroxide, slaked lime. Then write chemical equations for A with water. Also we have written. Now see, list two types of reactions in which we can identify. Yes, what are the two types of reactions? Type 1 is, it is a combination reaction. Am I right? Very good. It is a combination reaction. And the other one is, as it is giving us heat, it is an exothermic reaction also. So combination reaction as well as exothermic reaction. These are the two types of equations. Here the question goes very smoothly, children. The only point we have to remember is what is the particular substance which we are going to use. Am I clear? Right. Let us go over the next question without delay. Right. Mention with reason the color change when. So color change, I told you very clearly, color change definitely one question will be the color change. There are many reactions and very countable reactions in our textbook. So what are those? First one, silver chloride exposed to sunlight. What is the color change in this? Silver chloride when exposed to sunlight. What does it happen? It decomposes into, very good answer I am getting, Gaming Studio, very good. So it is Ag plus Cl2, 2Ag plus Cl2. And one more point children, when we are giving these equations, some will be asking me, sir, do we need to balance the equation definitely or not? See here, for certain reactions they will be asking us to balance the equation. And for certain reactions they will not be asking us. In that case also, suppose if you are confident, then you can balance and leave it. If you are not confident, if you are feeling little bit time taking process, avoid it. Avoid, better don't. Because if you are balancing, that answer should be correct. If you are not, if you are giving a wrong equation, that gives a wrong impression for the examiner. So do not do such kind of mistakes. Am I clear? So 2AgCl gives us to 2Ag plus Cl2. What is the color changer? The silvery white substance will be converting into a silver color, which gives you grayish residue at the end. So grayish color. So silvery to grayish color. Can anybody identify what is the reason for this grayish color? Silver is silvery white, but we are writing grayish color. Why? Why are we writing grayish color there? When the silver is clearly, we are all seeing it is silvery white in color, then why do we mention it grayish? Because it is involving with atmospheric sulfur to give silver sulfide, which is a passive substance which is not observed out. So we call it as grayish substance, so color change. Whereas the next question, copper powder exposed to air. I hope this answer everybody will be giving me, right? Come on, quick. What is the color? What is the color of copper when exposed to air? Copper when exposed to air forms dash. Come on, quick children. Yes, very good. Right. Green color. It gives the brown colored copper. The brown colored copper is giving you greenish. What is the substance here? Right. Basic copper carbonate. CuCO3 dot CuOH twice. Here air indicates what? Air indicates carbon dioxide, a bit of oxygen along with moisture. Gives you greenish color, basic copper carbonate. Right. So green color. Third one you see. A piece of zinc is dropped in copper sulfate solution. Lab manual question. A piece of zinc dropped in copper sulfate. It gives you zinc sulfate plus copper. Here what happens? Here the reaction is zinc getting displaces the copper and the copper is coming out. So what is the color change here? Copper sulfate is blue color. The blue colored copper sulfate is getting changed into white. This is one. And second observation is what? The copper gets deposited on the zinc metal. A brown coating of copper. A brown coating of copper is getting deposited on the metal. Am I clear all of you? Right. Now coming to the next question. I hope I am clear all of you, right? Okay, very good. Let us move to the fifth question. Lead nitrate solution, here again, is added to a test tube containing potassium iodide solution. Activity 1.2, textbook. Lead nitrate, PbNO3 twice. These are all notified questions only. Nobody is going to cross you about these questions. Potassium iodide gives rise to potassium nitrate plus lead iodide. What are the color changes here? He is asking to name and color of the compound precipitated. Precipitated. What is the precipitate here? Lead iodide is a precipitate. And what is the color here? Yellow color precipitate. Yellow color precipitate is observed and that is lead iodide. Name it. Next question. Write the balanced chemical equation. We have to write a balanced chemical equation. So let us start with nitrate. During balancing, one more point we need to remember that suppose if you find a polyatomic ion, balance it first. Because do not separate the atoms in the polyatomic ion. So nitrate we have here. So how many nitrates we are having here? Nitrate as a whole we have 2. But here we have only 1. So multiply with 2. So 2 will be the coefficient for KNO3. So now the nitrates are balanced. Now come to metals. Lead. How many leads are here? 1. Here how many do we have? Here also we have 1. So lead is balanced. So next let us go with potassium. Potassium how many are there? Potassium we have only 1. But here we have potassium's 2. So multiply with 2. Automatically the iodine gets balanced. So balanced chemical equation is PbNO3 twice plus 2Ki gives rise to 2KNO3 plus PbI2. The easiest method is first of all balance the polyatomic ions. The problem will be solved. Automatically the remaining atoms will come fast. Right? Clear? Children, clear all of you? Right. Very good. I am getting Atmana. Very good. Abhinav. Very good. Safin. Very good. Praveena. Yes. Direction. Good. 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 Next question we will go. 2 grams of ferrous sulfate dry boiling tube. Page number 8 NCERT textbook. Ferrous sulfate equation. What is the color of ferrous sulfate? The other day one child was asking, so what shall we do, sir? How shall we start, sir? Shall we start according to the textbook or shall we start according to the color of the substance? We all know that ferrous sulfate is green in color. So shall we start with the green color means we have to write FeSO4 7H2O. Remember children, when you are asked such kind of question, directly you can go with the textual equation. FeSO4 on heating gives rise to. FeSO4 on heating gives rise to Fe2O3 plus SO2 plus SO3. But if you are confident of the change, because the color change onwards we need to explain. If you wanted yourself to have a good impression by the examiner, start with FeSO4 7H2O. No problem. the teacher will be able to give a mark. FeSO4 dot 7H2O, which is an apple green color. So this one on heating loses water molecules. Dehydration takes place, it loses water molecules, becomes N-hydrous iron sulfate. It forms FeSO4. So this one here, what happens? Color fades. Color fades. Now this color faded FeSO4 on further heating. It now undergoes decomposition and forms Fe2O3 plus SO2 plus SO3. According to the textbook, only up to here it is given for you. But if you wanted to be clear with the examiner, let us follow this. There is not a hard and fast that you have to follow only that part. From here if you write, the teacher is very clear. Here you can write reddish brown color. Reddish brown. Right, so that is about the equation. So green colored ferrous sulfate, FeSO4 7H2O, on heating loses the 7 water molecules to form FeSO4, and that FeSO4 undergoes further decomposition in the presence of heat to form Fe2O3 plus SO2 plus SO3. Very good children, very good. So that's one. So next one what? Write balanced equation. You have to write the balanced equation for these children, right? Let us go for the next point. See, this is one more question which is normally given. A little bit tricky question. So, salt A is commonly used in bakery products. Okay. As soon as you listen bakery products, certain words are very, what you call, eye catching. So, they will catch your eye very quickly and get into the topic very fast. So, bakery, if you observe, or sometimes they'll give pakoras, sometimes they'll give cakes, pastries. Whatever it is, the substance will be NaHCO3. NaHCO3, sodium hydrogen carbonate or sodium bicarbonate. So this NaHCO3, what is being done? Listen here. On heating, this reaction we did not find earlier. This is from the middle of the book. So on heating gives a substance, another salt, B. This is A. Is giving you B. What is B? B means Na2CO3 plus, to remove the hardness of water, and gas C is involved. What is gas C evolution? Carbon dioxide along with moisture. Gas C. So A is sodium bicarbonate, B is sodium carbonate, and C is carbon dioxide. Listen children. So these are the three. First of all, identify A, B, C. And then what he is telling, gas C is evolved, this gas C when passed through lime water turns it into milky. So confirmatory test, whether C is giving you lime water or not. Yes. C, carbon dioxide, lime water test plus calcium hydroxide gives you calcium carbonate plus water. So lime water test. Yes, exactly. I want everybody to just participate fast. Participate in the chat and then give the answers very quickly. Right. Okay. Good. Right. Let us go for the next question. Yes. What are strong and weak acids? So theoretical question again. What are strong and weak acids? How can you define? Sometimes they'll give direct question. 90% will be indirect. That 10% will be knowledge based questions. So what are strong and weak acids? Strong acid means an acid which is able to produce more number of hydronium ions. Hydronium ions, if you are able to get hydronium ions in a more extent, so we call it as strong acid. Whereas what is a weak acid? Less number of hydronium ions. They're fast, whether it is giving you more number of H3O plus or less number of H3O. Or otherwise, if you are not able to remember hydronium, write it as which is able to release more number of H plus. Releasing side, there are two words here, remember children. One is releasing and one is producing. HCl releases H plus, but the same HCl with water forms H3O plus. So write it very clearly, okay. If you are mentioning hydronium, write it as producing hydronium ions. If you are mentioning H plus, mention it which is releasing H plus. Am I clear, all of you? Don't get confused with both of them. The words are because keywords are very important for a definition and for a statement. So whether it is releasing H plus or whether it is producing more number of H3O plus, make it very clear. And now identify the question here. Identify strong acids and weak acids. Remember here, any organic acid, consider it as a weak acid only. And most of them are also edible by us. So weak acids. Along with that, carbonic acid also can be added. H2CO3 also can be added. The remaining all strong acids only. So basing on that, hydrochloric acid, then nitric acid and sulfuric acid. These three are strong acids. And the remaining one are weak acids. Acetic acid, citric acid, formic acid, etc. So these are about the list of strong acids and weak acids. Similarly, when you go for bases, let me give you an idea. Bases, if you take the four high reactive metals, so-called potassium, sodium, calcium and magnesium, their hydroxides, they are strong. The remaining are weak. So only that remembering. So we have very good number of acids and bases, but strong count is very less. If you can remember that, very easy to remember those. So in the acids, hydrochloric acid, nitric acid, sulfuric acid and phosphoric acid. Whereas in bases, sodium, potassium, calcium, magnesium, these four hydroxides. Other than these, every substance is a weak. So that's an idea for you. Clear, children? With the same spirit, let us go for the next question. Right. Okay. Next, a dry pellet of caustic soda. Here there is one more new word, caustic soda. What is caustic soda? Anybody who will give it? Yes, Advik Jain, very good. Yes, Rahul, nitric acid is also a strong oxidizing agent. Very good. So remember every point. So which way the question will be asked, we can't guess. So we need to be alert with all the textbook in our mind. Right? Come on. A dry pellet of caustic soda. What is caustic soda? Very good, very good. I got the answer. Who is the first one to give? Yes, Atmana, yes, Tilottama. NaOH, caustic soda. It is moist, absorbs moisture and turns sticky. It turns sticky by absorbing moisture when kept open, right? And a byproduct of chloralkali process. So we have to now rewind or review about the chloralkali process. What is chloralkali process? Chloralkali process. What is it? Brine solution. Brine solution, when electrolyzed with water in the presence of electricity, it forms caustic soda NaOH plus Cl2 plus H2. Whether it is required or not, remember children, whether it is required or not, write the equation with a pencil at the side of examination, right? Now when you write like that, you will get an idea, oh, this is the position. Now continue the question. So chloralkali process we have written, caustic soda also we identified. Identify B. So B is sodium hydroxide. Next one is what? Identify the gases released during this process. What are the gases? One is chlorine gas and the other one is hydrogen gas. So hydrogen and chlorine are getting released. So what type of reaction occurs when B is treated with an acidic oxide? Listen again a point. So B, NaOH, is made to react with an acidic oxide. Acidic oxides are what? None other than non-metallic oxides. Non-metallic oxides. Right here, carbon dioxide. What is formed here? It forms Na2CO3 plus H2O. That means a salt is being formed. A salt is being formed. So write a balanced equation for one such solution. So for this, NaOH plus CO2 gives rise to Na2CO3 plus H2O. We have to balance it. This is also asked in one of the board examination question. Okay? Right. So you have to balance by yourself, children. We are not going to waste much of our time now. Let us go for the next question without wasting. So wherever there is balancing, I will be leaving it for your justification. You have to balance. And then if you get a doubt in balancing, then message me in the chat box. Then we can review back. Okay? Now let us go for the next question. Carbon prefers, let's go for the carbon compounds also. Carbon prefers to share its valency electrons. Listen this question, children. With other atoms of carbon or with atoms of other elements rather than gaining or losing the valency electrons. In order to attain noble gas configuration, give reason. Such a big question. Actually, they can be very similar. This is asked in 2022. 2022 in one of the set. In India it was asked. So this question normally what we say, this is an other form of a question. What is that? See here. Let me write down that question. Why do carbon prefer covalent bonding? Covalent bonding rather than ionic. This is one question. Or why do carbon not form C4 plus or C4 minus? For both the questions the same answer. So this question is, they have twisted it. Yes, very good. I got the answer already. So these are the two other forms of question. Any way the question can be projected. So when such kind of things are there, what do you say? You need to see with the structure of the carbon. Carbon, atomic number 6 with the configuration 2, 4 means as per the Bohr's atomic theory and the stability concept, an atom which contains 8 electrons in the outermost shell is supposed to be stable. So it has got 4. That means it can take +4 or can take or give you -4. But it does not prefer both. Why? What is the reason? Listen here. If it wants to form +4, it has to lose 4 electrons. It will not do. Why? Because if you wanted to remove 1 electron from the outermost shell, listen children, if you want to remove 1 electron from the outermost shell, it will be losing large amount of energy. For 1 electron, if energy has to be spent, for 4 electrons, how much of energy has to be spent? So more and more amount of energy has to be spent to lose 4 electrons. And with that, what is it going to attain? It's going to attain the configuration of helium, a small atom. So which is not justifiable. So no losing 4 electrons. Same way, if it wants to gain 4 electrons, if it gains, what will happen? If it gains 4 electrons, total electron number will be 10. But number of protons in carbon remains only 6. So 6 protons have to bear 10 electrons on its head. 6 protons have to bear 10 electrons on its head, which is not feasible again. Instead of that, it prefers sharing of electrons. It prefers sharing of electrons. So this is one of the important questions. Page number, you can see in the page number 2 of the chapter. Right? Now go for the next question. What is observed when carbon dioxide gas is passed through lime water for a short period and for a longer period? Short period is what? Longer period is what? For short duration, what happens? Carbon, already we have discussed this in the previous topics. But again, just have a review because this is very important, because definitely lime water test will be coming only 100%. So we get calcium carbonate, lime water, milky, and then water. So this is the short duration. Longer duration means what? If we continue to pass, again CO2 plus CaOH twice forms calcium carbonate plus H2O. On continuation, long duration, continue passing CO2. It forms a clear solution of CaHCO3 twice, a clear solution. Here it is white precipitate. It is a white precipitate and here is a clear solution. Am I clear to all? This is about the long duration test. Short duration and long duration. Yes, very good, very good, very good. Yes, let me know how many students are there in the live. Let me know how many. Yes. Next question. Of sodium hydroxide is added to few pieces of granulated zinc metal. So 2 pieces of sodium hydroxide, NaOH, is treated with few pieces of zinc metal. What is formed here? Right. What is formed here? It will be Na2ZnO2 plus hydrogen. Na2ZnO2 plus hydrogen. So he is getting warmed, a gas involved, which is bubbled through a soap solution. Soap solution. Normally we call that pop test. What is that pop test? Whenever we send the gas through a soap solution, we take a gas and pass it through a soap solution. Here there is soap solution. And when we pass the gas hydrogen through the soap solution, it forms bubbles. So these bubbles will be coming out. Bubbles. And that bubble will be popped out. That bubble will be popped out. So we call it as a pop test. When we place a burning splinter near to the bubble, that soap bubble, right? Soap bubble will put off with a pop sound. So that's what we call it. That means the pop test for hydrogen gas. So write the equation, the chemical equation involved and the test tube to detect the gas. So detect the gas, the test. Right? Name the gas which will be evolved when the same metal reacts with a dilute solution of strong acid. So here we have seen the equation of the reaction and we have seen the pop test. And now he is asking us to write an equation with a dilute solution of strong acid. That means the same metal is asking. Metal will be zinc. So zinc with any acid. So it will be zinc chloride plus hydrogen. That means metals when treated with acids, not only with the bases, with acids, it forms salt and hydrogen gas. Okay, clear? So that is all about the reactions. And here what do we know? A substance is getting reacted both with acid and also base. Such kind of substances, oxides, are substantially amphoteric in nature. Amphoteric in nature. Am I clear, children? Let us not waste the time. Yes, very good. Next question. Right. A non-metal X exists in 2 forms, Y and Z. What is it? Come on, quick. Come on quick, come on quick. What is the X, what is Y, what is Z? So X, we need to identify, Y, we need to identify, Z, identify. What are the hints here? Z is a good conductor of electricity. Z is a good conductor of electricity. And Y is hard substance. And both are allotropes of X. So X will be, yes, very good, carbon. And Y will be diamond. And Z will be graphite. Yes, very good. So this is about X, Y and Z. Next question. A student took a small amount of copper oxide. This is a very different question which we never find in the textbook. This also is asked in last year, 2023 question this is. Small amount of copper oxide is taken in a conical flask and added dilute hydrochloric acid to it, HCl. What do you get it? And on constant stirring, he observed a change in color of the solution. First of all, let us finish up the equation here. CuO plus HCl, what is it? Yes, it forms CuCl2 plus H2O. Very good, very good. Now, what is the color of this? What is substance called? This is copper chloride. And copper chloride is greenish in color. So, your copper oxide is black in color. The black color copper oxide is getting changed into greenish color copper chloride. So, write the name of the compound formed and its color. Name of the compound formed is copper chloride and the color is greenish. And the balanced equation you can write for this. So CuO plus HCl. So this if you balance it, what do you get here? 2 CuO plus 2 HCl gives us to CaCl2 plus H2O. That is a balanced equation. Am I clear, children, all of you? Right, very good, very good, very good. Right, greenish color. Right, next question. When a metal X is treated with cold water, let us see children, this is a very important question, okay? This was also asked around 2-3 years back. So, let us solve this question. Here there is no direct hint. A metal X is reacted with cold water. Metal reacting with cold water means it must be either potassium, sodium or calcium for us. We are going to deal with only these metals. So one of these will be there. And he has got X with water forms salt Y along with hydrogen gas, that is clear for us. So what is that Y? How do you identify that Y? What metal? Because most of the metals are those three can give you hydrogen gas, can give you salt. That what is that Y? He has given for us the molecular mass as 40. We have to go to grade 9 again. See here, that is YOH, sorry, XOH is given here, where the mass of hydrogen is 1 and mass of oxygen is 16. So here, mass of hydrogen is 1 and 16. And this is X. Together we have to get 40. So here X plus 16 plus 1 is equal to 40. Am I clear, children? What is the answer? X reacts with water to form Y. That Y is what? XOH. And that XOH mass is equal to 40. We know that hydrogen is 1 and oxygen is 16. When you substitute that in O and H, so we get X plus 17 is equal to 40 and X is equal to 40 minus 17 is equal to 23. That means the mass of X is equal to 23. Now we are near to the answer. And which element has got 23 mass? Which element has got 23 mass? Yes, It is none other than sodium. So what is Y? Y is equal to XOH is equal to none other than NaOH. NaOH. So this is the salt which is given, and the metal X is Na. Metal X is Na. So that is how we identify the question and write the reaction involved. So Na plus H2O, the final equation will be Na plus H2O gives rise to NaOH plus H2. Right, I am getting the answer right, all of you? Very good, Na, very good, very good. So this way, I hope you are all taking down the answers also, right? Very good. So next, go for the next question. Next question will be, how is copper extracted from its sulfide ore? This is also a process where normally question will be asked. These kind of questions also will be asked. So from extraction of metals, this is very important. And asking you to draw a labeled diagram for the electrolytic process also. Listen children, let us not waste our time and carry on to the point. Copper extraction. Normally copper is extracted. Copper is a low reactive metal which is extracted from its sulfides, copper pyrites. So Cu2S is the ore of copper. Cu2S is the ore of copper. So what do you do? Whenever we have a sulfide ore, what are the three steps? First step is concentration. Second step is reduction. Third step is refining. He is asking how it is extracted from the sulfide ore. So concentration is done by froth flotation process. Let me briefly explain what is froth flotation process. Froth flotation process means here we take a very big large tank with pine oil inside. Pine oil. Pine oil nature is to give you froth. So this ore has to be crushed first of all. We crush into fine powder and we mix with the pine oil and centrifugate. When we centrifugate, just like we prepare cotton candy, when we centrifugate, the less denser sulfide particles will come out along with the froth. The less denser copper sulfide particles will come out as the froth. And separate the froth, clean with water, we get our ore separate. So this is the first step. Whether you write this or not, it is only optional for you. Just mention it will be concentrated by froth flotation process, that is enough. Next, go for the second step. The second step is reduction of the ore. How do we reduce? Before reduction, we have to convert into its oxide. So let us go for roasting process. Roasting. Roasting means heating in the presence of air. Heating in the presence of air. We get copper oxide plus sulfur dioxide. Oxide we got. So we know that during reduction, oxides are very much essential for us. So we have to convert the sulfide into oxide by roasting process. So we have now converted into oxide. Next step is reduction of oxide. Reduction of oxide. How do you reduce it? Reduction of oxide is done by a process called self-reduction. What is called self-reduction? Here what happens is ore is taken as a reducing agent. The copper oxide so formed, observe carefully children, copper oxide so formed on self-reduction with the ore particles itself. It forms crude copper. It forms crude copper along with the sulfur dioxide. This is called self-reduction. This is called self-reduction. With this we get the crude copper metal. Now this crude copper metal has to be refined. How do you refine it? Observe carefully, children, here. We have taken an electrolytic cell. Electrolytic cell we took, and inside we have taken electrolyte. What are the requirements for the electrolysis process? Here we need an electrolyte, we need an anode, we need a cathode, and electric circuit completion. So electrolyte is nothing but the respective metallic salt solution. So here I have taken copper sulfate, aqueous copper sulfate. The means copper sulfate solution I have taken. So this copper sulfate solution is blue in color. So I only have taken blue color. So this blue colored copper sulfate is taken, and then we immerse an anode and a cathode. Now what is anode, what is cathode here? Observe carefully, children. Cathode will be always a pure metal, and anode will be always an impure metal into purify. So the impure metal, which is an irregular shape, we just introduce as anode, and the pure metal we consider it as cathode. And these two are being connected with the help of a circuit. And when we connect the circuit, when you connect the battery, what is going to happen? Observe this only very careful. This process, what we took here, we took electrolyte, copper sulfate, impure copper anode, pure copper as cathode. These three substances. Now what is the reaction happening? See, observe carefully here. At anode, the first reaction takes place. At anode, what happens? The crude copper gets dissociated. It divides into Cu2 plus and releases 2 electrons. It releases Cu2 plus and 2 electrons. Observe carefully here. This one gets dissociated. Cu2 plus comes into the solution. And what is the charge of the cathode? Charge of the cathode is negative. Charge of the cathode is negative. So these electrons which are getting released comes and sits near the cathode. Copper dissociates into Cu2 plus and electrons. So these electrons will be passing through the circuit and waits near the cathode. Now this cathode is electrified. Now this cathode is electrified. It has accepted electrons of the copper. Now it is electrified means it is ready to accept a positive charge. Cathode is negative, so it is ready to accept a positive charge. So what is going to happen at the cathode? See here. At cathode, what will happen? The copper ions are accepted by the electrons to give pure copper metal. Am I clear, all of you? So what is happening? First we have roasted the ore and converted into copper oxide. Second, we underwent self-reduction, converted into copper crude metal. This copper crude metal has undergone electrolytic refining. For that, what did we do? Copper sulfate electrolyte. Then the impure metal is considered as anode and the pure metal string is taken as cathode. So on connecting the battery, on connecting the circuit, what is happening? The impure metal copper gets dissociated into copper ions and electrons. Now these electrons are coming towards the circuit and making the cathode charged. Now this cathode is electrified with electrons. Now these electrons, what they will do? They will in turn grab the copper ions from the solution and makes it deposited on that. So finally the pure copper gets deposited on this particular cathode. Slowly what happens? We observe the anode side copper is dissolving, and the other side, the cathode, copper gets depositing. So after a certain period of time, we can see that the complete copper, which is crude, gets dissolved. Then we can replace it with a fresh electrode of a crude metal. Here you observe one thing. Why are we dissociating and why are we associating? No change. In the anode, it is dissociating into ions. In the cathode, it is associating. Then what is the change? Why are you doing this process? During this process of anode and cathode, there is one magic which is happening. What is it? Certain impurities, crude form means impurities are very minimized. Such impurities are getting collected under the anode in the form of anode mud. Only to separate this anode mud we are going for this process. Impurities. Okay, this is about the refining of copper or extraction of copper from its sulfide ore. I hope I am clear with this topic, right children? Right? Okay then. Let us go with the next question. Give reasons. Yes, reasoning question will be there. One question definitely. So give reasons. Ionic compounds have higher melting point and higher boiling point. What is this? Ionic compounds have higher. Why? What is the difference between ionic compound and covalent compound? Listen carefully children. Ionic compounds are formed by transfer of electrons. Ionic compounds are formed by transfer of electrons. Since the ions are formed, transfer of electrons, the bond is very strong. Bond is very strong. Since the bond is strong, what happens? It needs more temperature to break. So to break needs more E. So high EP or high MP. Reason clear. Make it very specific. Go to the point, strike, don't beat around the bush. Second one, sodium is kept immersed in kerosene. Why? Because sodium is a high reactive metal and when exposed to air, it catches fire. It forms into oxide ash. It catches fire. It is violent in nature. Violent in atmosphere and water. So, store in kerosene. Clear all of you? Next, third question. Reaction of calcium with water is less violent. Why it is less violent? Because it is less reactive metal than sodium and potassium. So what happens here is when exposed to air, it reacts with a little bit delay due to which an oxide layer is formed on it. So that what happens? The reactivity goes down. If it is reacting very fast, what happens? It forms fire automatically. But it is slow down because its reactivity is little slow and the atom is also bigger in size. 4 shells it contains. So these all factors will make it, so it's less reactive in nature than sodium and potassium. Okay? Let us go for the next question. Write balanced equations to explain what happens when mercuric oxide is heated. We have seen just now about the copper. Let us see about mercury also. I am going little fast because we are running short of the time. Right, because you need to also prepare for exam, right? So, mercuric oxide, HgO. What happens when mercuric oxide is heated? Can anybody? What happens when mercuric oxide? Yes. Mercuric oxide, when heated, what happens? Mercuric oxide on heating gives directly mercury and oxygen. Here we need to balance it. So what do you get here? 2HgO forms 2Hg plus O2. simple heating. To refine, that means to convert the mercuric oxide into crude mercury. So we go for simple heating. That is the first equation. Second equation, you see aluminum treated with manganese dioxide. What is the reaction about? Aluminum, when treated with manganese dioxide, what do you get it? What do you get, children? Aluminum with manganese dioxide gives you, yes, it gives you aluminum oxide plus manganese. What do you call this reaction as? What do you call this reaction as? Right. This reaction is called, very good, Atma, yes, Vanessa, very good. This reaction is called thermite reaction, or we also call it as aluminothermite process. Is this reaction only for manganese? For other moderate reactive metals also. We can take even aluminum plus iron oxide. Here we get, what do you get here? Aluminum oxide plus manganese. Here we get aluminum oxide plus iron. Right, very good. Good. Gaming studio. Who is this gaming studio? Can anybody tell me the name of this fellow? Amina, very good. Yes, Karnika, very good. Mridul, very good. Right. Ahini, very good. So, aluminum plus iron oxide gives us to aluminum oxide plus iron. Very good. So, when you balance this, what do you get it? Let us balance both the equations without delay. So, here we have one aluminum, here we have two aluminiums. So, keep 2 before aluminum. Then what do you get? Two aluminiums, right. Manganese, 1, right. Oxygen, you see. Here there is a small twist. That's why I am stressing on this. There are 2, here 3. Let us flip it. Let us multiply this oxygen with 2. Let us multiply this oxygen with 3. Clear, all of you? First we balanced aluminum. Then when we came to the case of oxygen, we observed both are having different. 1 is 2, 1 is 3. Let us flip it. So 3, 2, 6, 2, 3, 6. Now again come to aluminum, which is not balanced. So here after balancing oxygens, we have got 3 manganese. Let us put 3 manganese before that. And aluminiums are 4. So 4 aluminum. So this is the final equation. What did we do? First we balanced aluminum. Then we saw what is the position of oxygen. We have seen it is 2 and 3. So we have cross multiplied it. So 2 times 3 and 3 times 2. We get 6 oxygens on the right side, products, and we have got 6 oxygens on the left side, reactants. So oxygens are balanced. Now metals can be balanced easily. So when you see aluminum, it is 4. Just keep 4 on the other side. And when we see manganese are 3, keep 3 on the right side. So the reaction is balanced. Same way go for this also. So aluminum plus iron oxide. Here we have aluminum is 1. Here there is 2. 2 aluminum. Here there is 2 iron. That's it. This is very simpler than that. 2Al plus Fe2O3 gives us 2. Al2O3 plus 2Fe. So they will not be asking this equation for definitely because it's very simple. They will be asking this equation for balancing. Either you need to get a clear-cut balancing part, or else you need to by heart and keep it ready-made. So that you don't waste your time, because examination point of view should not waste your time, should be specific with your answers. Let us go for the next question, children. Right. What happens when ethanol is heated with concentrated sulfuric acid? Right. Very good. Come on, quick. What is this? Right, Subhasri. Very good, Subhasri. Right. Now, let me know. What is the action of ethanol with sulfuric acid? Ethanol formula is C2H5OH. You are heating at the rate of 443 Kelvin with the help of concentrated sulfuric acid. What is the role of concentrated sulfuric acid? Come on children, what is the role of concentrated sulfuric acid? It is acting as a dehydrating agent. It removes water. It removes water. Yes, very good. Dehydrating and forms an unsaturated product called ethene. Unsaturated product called ethene. C2H4. What is the role here? H2SO4 is acting as a dehydrating agent. Dehydrating agent. Right. Let us go. They are asking to balance it. You can balance it later very carefully. Let us go for the next question. A salt X is formed and a gas is evolved when ethanoic acid reacts with sodium hydrogen carbonate. So here the question is ethanoic acid with sodium hydrogen carbonate, NaHCO3. What do you get? Come on, guess. Yes, very good. Already started answering. Right. The salt is formed. A salt is formed here, okay. And gas is evolved. A gas is evolved. Let us see what is that. When these two are undergoing reaction, it undergoes a double displacement reaction we have discussed previously also. It forms CH3COONA. What is the name? Sodium ethanoate. Sodium ethanoate plus carbon dioxide plus water. Right, very good. Rahul, very good. Arya, very good. Right. So, this is the equation we have got. Now, what is the next question you see? Up to this, everybody will do it. Now, what is the next punch you see? Describe an activity and draw the diagram of the apparatus to prove that the evolved gas in the one you have named. What is an activity you have to draw? So, you need to draw activity for this point. This equation, everybody. Now, activity to show that gas is carbon dioxide. What do you do here? Take a conical flask with a 1-hole rubber stopper and put a delivery tube and dip that delivery tube into the beaker where there is slaked lime. Right? Slaked lime you make it, and then here you take the substances NaHCO3 plus CH3COOH. So here you get carbon dioxide gas and you will be giving you milky white precipitate. Since the beaker is open, there might be interference of atmospheric carbon dioxide also. So, to confirm, leave the reaction for longer time, for long duration, like previously we have discussed. If you leave it for longer duration, atmospheric carbon dioxide will finish off and still CO2 is coming, it will make the solution to be clear. Later on, it gives you CaHCO3. Got the point clear? I made the activity in such a way that the beaker is open. When the beaker is open, the slaked lime will clearly interfere with the atmospheric carbon dioxide. So we will not identify whether the gas is CO to confirm or not. So what do? You leave it for some time so that the more and more carbon dioxide comes and involves with the slaked lime and makes that white precipitate to get a clear solution. With this, the question is done. Okay, so this is the equation. CH3COOH plus NaHCO3 gives rise to CH3COO Na plus CO2 plus H2O. Yes, very good. Right, let us go for the next question, children. Draw the structures of the following: butanoic acid and chloropentane. Butanoic acid and chloropentane. He is asking butanoic. Let us draw the butanoic acid. Butanoic acid. So acid group is COOH. So but means 4 carbons. 1, 2, 3, 4. Acid group means COOH. Now balance the hydrogens. Since there is only one, here you keep it. Here we will have. So CH3, CH2, CH2, CO. This is butanoic acid. Similarly, chloropentane. What is the pentane formula? Pentane formula will be C5H12. So chloro means you are removing one hydrogen and adding one chlorine. It becomes C5H11Cl. So it will be CH3, CH2, CH2, CH2 and one more CH2Cl. Since there is less space, I have made it condensed form, or else we elaborate like these structures. So this is butanoic acid and that is chloropentane. Okay, let us see the next question. How are the structures related? Come on, quick. Yes. How are the structures related? Structure 1 is given, structure 2 is given. What is the relation between these two structures? Let us, whenever they say relation, definitely it could be a homologous series or could be of the same family, same functional group, same. See there, how many carbons are there? In structure 1, there are 1, 2, 3, 4, 5, 6 carbons. And hydrogens are how many? 3 plus 3 plus 3 plus 3. 12 plus 2, 14. C6H14. It is C6H14. And what's the next structure? It is also 1, 2, 3, 4, 5, 6. 6 carbons. And it is also 3 plus 3 plus 3 plus 3. 4 plus 2, 6. So 14 hydrogens. So C6H14 is hexane. C6H14 is hexane. That means he has mentioned here the isomers of hexane. They have given you isomers of hexane. What are they? These two are isomers. Same molecular formula with a different structural formula. Isomers. Yes, isomers. Got the point? Yeah, he has asked you what is relation? The relation between both are, since they are having same molecular formula and different structural formula, they come under isomers. You can draw still more structures also. At home you can try peacefully and you can make it hexane isomers. How can you call it isomers? See here. What is IUPAC name of this one? Can anybody give me IUPAC name of this? The IUPAC name will be 2,3 dimethyl butane. 2,3 dimethyl butane. And here it is, when you take this as the long chain, second carbon, 2 dimethyl butane. Isomers are what? 2,3 dimethyl butane and 2,2 dimethyl butane. Isomers of hexane. Am I clear? Note down the name of IUPAC. Sometimes they may be asking what are their IUPAC names. IUPAC names for the first one is, it is on second carbon, it is on third carbon. So it is 2,3 dimethyl butane. 1, 2, 3, 4. 4 carbons are there. 2,3 dimethyl butane. And the next one is 2,2 dimethyl butane. Am I clear to all of you? Let us go for the third question. Differentiate between saturated and unsaturated hydrocarbons on the basis of general formula. So, saturate, unsaturated, how can you differentiate? Saturate compounds. Listen carefully here, children. Saturate compounds will be having general formula CnH2n plus 2 alkanes. Whereas unsaturated will be either CnH2n or CnH2n minus 2. Alkenes or alkynes. He's asking regarding general formula with an example. You can write ethane. You can write either ethene or ethyne. Clear? This is how we have to give the structures for the carbon compounds. Am I clear, all of you? Hydrocarbons. When you come to the case of testing, if it is a physical test, go for a flame test. If it is giving you blue flame, it is a saturated compound. If it is giving a yellow sooty flame, it is an unsaturated compound. That's a physical test. Then if it is only a chemical test, what you do? Bromine water. A saturated compound, bromine water, color is retained, brown color. Whereas if it is a unsaturated compound, whether it is an alkene or an alkyne, the blue color, that means the bromine color gets disappeared. So in this way we can go for a tests of saturated, unsaturated. So they will be asking either differences between saturated and unsaturated, or they ask about the physical test or chemical test, how to identify saturated and unsaturated hydrocarbons. Very clear, children? And the IUPAC naming, be very careful for it. Okay, give the least numbering for the substituent always. Coming to the next question. Right. Suggest a safe procedure of diluting a strong acid. This also we have done previously. See the question how it is asked. They can be asking like whether we have to add acid to base or base to acid to water or water to acid. But what did they mention? They asked what is a safe procedure to dilute a strong acid. What is this? Yes. Add acid to water. Yes. Adding acid to water. Because it is less exothermic than the other way. Right. So first one. Second question is what? Name the salt formed when sulfuric acid added to sodium hydroxide and write its pH. Sulfuric acid plus sodium hydroxide. Asking you the salt which is formed, sodium sulfate plus water. What will be the pH of the substance? Come on. Somebody is telling sodium chloride. My dear children, see, observe the question carefully. It is sulfuric acid. So what will be the pH of this sodium sulfate? See again, Pravina, make sure that your formula should be proper, children. We are doing a large amount of hard work whole year. At the end, if you write a small formula mistake, you are going to lose the mark. Don't lose your mark at the cost of your little bit of homework. Work it at the back. Sodium, valency 1, sulfate, valency 2. When you crisscross, you get Na2SO4. What is the wrong in making one trial? Why do you want to go for risky thing? So yes, Rahul, it is neutral. Very good. So pH will be 7. pH will be 7. Very good. Next, third question is, dry HCl gas does not change the color of dry blue litmus paper. Why? You all, number of times you have studied also. But still they are asking. What answer do we write here? 2023 question, last year only. Very simple question, 3 marks. Imagine how do you get it. So dry HCl, what happens here? Dry HCl cannot dissociate into ions. No ions, no conductivity. Ions, no conductivity. Very simple logic. Dry HCl cannot dissociate. It's a gas. It's a neutral gas which cannot dissociate into ions. That's why we have to accompany with the a little bit of water, aqueous nature. In the aqueous nature only HCl can dissociate into H plus and Cl minus ions. Am I clear, all of you? Right, children. So these are the three answers. For this you are going to award 3 marks. Okay? Next question. Right. Yes, very good. Write the formula and dot structure of carbon tetrachloride, CCl4. Can anybody tell me why is it used for? Formula will be CCl4. And whenever you write a dot structure, write down its configuration. Carbon, atomic number 6, configuration 2, 4. So it needs 4 electrons for getting satisfied, means stability. Chlorine, 17, 2, 8, 7. It also needs 1 electron. So here carbon, which has got 4 electrons in the outermost shell, shares its 4 electrons with 4 chlorines. So what will happen? The bonding goes on like this. In the other side, and put boxes for this. Bonds. So carbon tetrachloride, electron dot structure this is. That is the first question. What is saponification? What is saponification, anybody? Right. What is saponification? Reaction of, what happens here? Oil or fat. You mean ester. Ester on hydrolysis, in the presence of base, forms soap plus glycerol or alcohol. Generally glycerol or particularly alcohol. Since we have taken here equation, what saponification reaction involves. So here if we take example CH3COO C2H5, ethyl ethanoate. This one on hydrolysis when it forms CH3COOA, sodium salt of acid, CH3COONA plus here we get C2H5OH. Since we have taken here ethyl compound, we got alcohol. If we take some other compound, so then we will be getting glycerol or any alcohol will be getting it. So this is the reaction of saponification. What is saponification? Oils or fats or edible fats. So these fats, when you are hydrolyzing with the help of an alkali, it dissociates into soap and alcohol. So soap gets precipitated. I hope you people have been doing in your school labs. Take some oil, put some sodium hydroxide solution and stir it for a longer time along with sodium chloride. Okay, here since the question is not given but still I am going to discuss. During saponification, listen children, going to the end, during saponification we are adding a bit of NaCl. Why? They will ask you for 1 mark question, right? Why do we add NaCl during saponification reaction? During preparation of soap, why do we add? Come on. We are adding NaCl to precipitate the soap, because whatever the soap we are forming will be like a colloid. The particles are bigger but they will not come together. But if we add sodium chloride, a pinch of NaCl will precipitate the soap into a big mass. Then filter it and then put some pressure. It converts into a nice cake of soap. So NaCl is to precipitate the substance, precipitate the soap. Okay, clear children? Right, very good, very good, very good. Next question. Yes, let me see how many of you are able to solve this question. Come on, quick. A compound C, this is a very interesting question. Okay? A molecular formula is C2H4O2. I wanted everybody to, Rahul, come on, quick. Rahul, quick, make it fast. Do not get diverted, children. Nabiha, Rahul, please do not get. Come on, Mridul. Yes, come on, answer. Right. It is CH3COOH. Very good, beta. CH3COOH. Very good. Concentrate. You are going to have exam within 24 hours. Quick. Plus, reacts with sodium metal to form CH3COONA plus hydrogen gas. Very good. Done. The first substance. Compound R. So compound C is here. Reacts sodium metal to form compound R is here. CR, both are formed. Now see what is happening. And hydrogen gas pops out. Right. Compound C on treatment with alcohol. Listen carefully, children. Compound C on treatment with alcohol, A, in the presence of acid, forms a sweet smelling compound. Yes. What is the substance? What is that alcohol resulting here? CH3COOH plus alcohol gives rise to C3H6O2. What is the alcohol? Come on, quick. What is the alcohol here? What is the alcohol? Come on. Atmana, check out. See, compare with the formula. Atmana. Praveena. Advik. Yes, Advik is right. What is it? It is methanol, but not ethanol. Children, look at the product, children. This question is very, very important and crucial. Most of us make mistake in this. 70%, 80% of children make mistake of this because the formula is C3H6O2. Suppose if you are thinking CH3COO, C2H5, check out this. How many hydrogens are there? C3H8O2. But the question is H6O2. So it is not ethanol. So it will be C3H6. So it will be methanol. CH3COOH forms CH3COO, CH3. So it will be 1, 2, 3, 4. C4H8 will be there. It should be C4H8, but it is C3H6. It is CH3COO, CH3. Dimethyl ester, C2H6O2. Clear, all of you? So make sure that you people are reading the question carefully and then only you are answering to the point. See, a small mistake costed you for an answer loss. Here means I can rectify your mistake through the system. But in examination, who is going to check your answer, children? You have to check by yourself. Double cross check the question, double cross check the formula, and double cross check the answer. Then only your answer will be right, or else you will be lost. Why students stand in here 99 out of 100? Why don't they go for 100 out of 100? Because of these silly mistakes only. Will cost you 1 or 2 marks, which you can never get back again. Here before the system, before the camera, I am having your chat box. I can see here, I can rectify your mistake. But in examination, nobody will be there, children. You need to do by yourself only. Please be alert. Okay? Right. So here, once again, C is, what is it C? Acetic acid. What is R? Sodium acetate. Then what is S? S will be CH3COO, CH3. And R. What is R given here? On addition of NaOH to C, it gives R. NaOH to C. NaOH to C. NaOH to C. What is C given here? CH3COOH plus NaOH gives CH3COONA. That is R. So here C is given, R is given, S is also given. Then what is A? Where did we find A here? Yes, alcohol is A. This is A. Okay, children. So we got C, A, R and S. So kindly go through very carefully and answer these kind of questions. Once it is lost, the time is lost. We can't get back. Right. Let us go for the next question. Organic compound A on heating with concentrated sulfuric acid. This already we have done it previously. But there is a next part. See that question part. So organic compound A treated with concentrated sulfuric acid is giving you compound B, which on addition with hydrogen gives, in the presence of nickel, gives a compound C. And 1 mole of C, second reaction, on combustion forms 2 moles of carbon dioxide and 3 moles of water. So identify A, B, C at the equation. I hope you must have done already by this time. Right? Okay. So A, what is organic compound A? That is ethanol. Ethanol gives ethene, C2H4. C2H4. And this C2H4, it gives with hydrogen C2H6. So here C is C2H6 plus oxygen gives a CO2 plus H2O. So that is the equation. So here how many hydrogens are there? So 2 carbons, 2 carbons. 6 hydrogens, 6 hydrogens. How many oxygens are there? 4 plus 3. So it will be 7 by 2 we have to take. So when you balance it, you get 2C2H6 plus 7O2 gives rise to 4CO2 plus 6H2O. A balanced equation if they ask. If they don't ask, no need to balance because it is a fractional coefficient. Don't take the risk of balancing. In case if you lose, you will be losing the mark. Okay, children? Make sure that. So, what is A? Ethanol. What is B? Ethene. What is C? Ethane. And then what is the rest? That is a combustion of ethane. Gives you carbon dioxide and water molecule. Am I clear, children, all of you? Any doubts? Right, very good. Next question. Right. Oh, very good question. This is also asked in 2022 question. Name the functional group present in these 2 compounds. What are the 2 functional groups here? The 2 functional groups are, here we have got CHO. Is not visible. Okay, let me change the color. CHO. CHO. So CHO refers to aldehydes and they will be having suffix of Al in the IUPAC name. So it is 1, 2, 3 carbons. It is propanol. Propanol. This is also propanol. What is this one? This has got 2 carbons. So this is ethanol. Ethanol, propanol. So 2 carbons, 3 carbons. So what is he giving you? Functional group present, alcohol. So it is aldehydes. General formula. What is the general formula of this? If you observe the general formula of an aldehyde, it is CnH2nO. CnH2nO is a general formula of aldehydes. CnH2nO. See here, C3, H6, 1, 2, 3, 4, 5, 6. Oh, CnH2n. Here you see C2, H4, O. So CnH2nO is the formulas. So general formula is CnH2nO. Coming to the next question. State the relationship between both the compounds. What is the relationship between both the compounds? What is the relationship between both the compounds? Yes, both the compounds belong to homologous series. Both are homologs. Both are homologs. Homologs means which differ with the difference of CH2. Difference is CH2 here. That means 14 units. What is the last question you see? Draw the structure of any other compound having similar functional group. That means he is asking to write one more functional, one more homolog. So here ethanol, propanol, let us go to butanol. Let us write butanol here. Butanol. So CH3, CH2, CH2, CHO. You want it as a structure? CH3, CH2, CH2, C double bond OH. This is the structure of ethanol. So, butanol. Am I clear, all of you? This is about IUPAC naming or the functional groups or the structures. Everything will be combined in this question. Let us go for the next question. Going to finish, don't worry. Right. Consider the following molecular formula of carbon compounds. Acetic acid is here, methanol, ethane, then propine, and then butane. So butene. Which one of these compounds belong to homologous series of alcohols? Alcohols is second one. Answer is alcohols. Right. Next one. Identify the compound having triple bond between two carbons. Triple bond means alkyne. Triple bond. Triple bond alkyne. C3H4. And then write the first member of homolog of the compound 1. Compound 1, this is a bit difficult point. Look after all of you. First compound of this homolog. This is getting CH3COOH. We have to subtract CH2 from this. So we get here formula HCOOH. This is called formic acid or methanoic acid. Methanoic acid. Am I clear to all of you? This is about the question. So these are the answers. Let us go for the next question without a delay. Another one more question is there. The table provides the pH values of 4 substances. This is very simple answer. Can anybody give me the answer fast? Come on, come on, come on. Mridul, come on. Advik, come on. Rahul, come on. Atmana, come on, come on. Subhasri, come on fast. What are the answers for this? This is going to end within a short while. Okay, don't. Right. What is the answer here? We have to go for increasing order of the pH. Increasing order of pH means increasing order of H plus ions. So H hydronium he is asking. That means we have to go from less acidic to more acidic. Less acidic to more acidic. Less acidic means we have to go for more basic nature. Am I clear? So what is the answer here? Less acidic is 11. Look at children, all of you here. Less acidic is 11. So S is less than Q, less than R, less than P. S, Q, R, P. Option is 3. Less acidic to more acidic. P has got more pH value. That means more acidic character, more hydronium ions. So answer is option C. Yes, very good, very good, very good. Right. Okay. Next question. This is very simple question, but a little critical. Calcium oxide can be reduced to calcium on heating by sodium. Calcium oxide plus sodium gives rise to calcium plus sodium oxide. He is asking which is an oxidizing agent. I told you last time also, blind shot. In the reactant side, if there is oxygen, that is an oxidizing agent, very blindly. No other consideration here, directly go and put it. Your answer is right. So answer is calcium oxide, D. Okay children, let us go for the last and final question. A heart-throbbing question. Let me see how many are going to answer this question. Read the question. A student added 10 grams of calcium carbonate in a rigid container, secured it tight and started to heat it. He made it tight. After some time, an increase of pressure was observed. Okay. The pressure reading was then noted in interval of 5 minutes. For 5 minutes, 0, 5, 10, 15. And plotted a graph between time and the pressure. As a graph shown here. Now what is the question? During which interval of time did maximum decomposition take place? Right. Maximum decomposition means how much of decomposition has happened. So 0 to 5, this is one range. 5 to 10, this is another range. 5 to 10 minutes. Here this is. Then next one, 5 to 15 here. So how much is getting here? So 0 to 5 is the higher. Answer is D. 0 to 5. Here maximum decomposition take place at this region only. Up to 5 minutes. Where the 5? Up to here, sorry. Up to here 5 minutes. Whereas here what happens? Very less, only 2 steps. And here also only 2 steps. Here there are 1, 2, 3, 4. 4 compartments are filled. Here only 2 compartments, here only 2 compartments. That means maximum decomposition took place in this area only. So answer is 0 to 5 minutes. Am I clear children, all of you? So this is how we end up all the 4 chapters children. I hope everybody have got a clear idea about all the 4 chapters, the way of questions, the mode of the questions being asked. Save this video and then try to revise it before going for exam also. Okay, within shortly my biology colleague Mr. Krishnadas will be joining you. Thank you and all the very best for your examination children. Okay, right. So stay tuned, have a sip of water or have a biscuit and come back. Meanwhile, my colleague will join you. Thank you children, bye bye.
Hi all, welcome to Brilliant Qatar's biology classes of grade 10. Today we are going to have a rapid revision of all the chapters in biology, important topics and all. I'll be revising along with a few questions. So just sit, relax and try to recollect all the things what you learned, and we will have a quick revision. So hope you will enjoy the session and you will get a lot of output from this also. So let me start with the revision class. First question, give the energy transformation that take place in the process of photosynthesis. In photosynthesis, you already know it's the conversion of light energy into chemical energy. So that is the answer that you have to write. Then define photolysis. So what is photolysis? So you know that in photosynthesis, there is carbon dioxide and water that is actually used as raw material in presence of sunlight and chlorophyll in order to make carbohydrate, that is glucose. Byproduct is oxygen as well as the water will be coming out. So in this process, oxygen that is liberated, it's actually coming from oxidation of water. So breaking of water to release electrons H plus and the oxygen, that only we call it as photolysis. And it takes place in light reaction. Hope you are getting it. It takes place in light reaction. The next question, how does water affect the rate of photosynthesis? Actually, if water is not available, they cannot perform photosynthesis. It's the raw material for performing photosynthesis. In that, after splitting of water, the electrons and H plus that is coming out only is used for producing ATP and NADPH. Like that is water has been used in photosynthesis. Now explain why the rate of photosynthesis in plant is low in both at lower and higher temperature. Understand, at low temperature, the enzymes will become inactive. The enzymes associated with photosynthesis become inactive at low temperature. That is why the rate is declining. High temperature, what happens is enzymes will become denatured. Denatured means it will get damaged. So in both the cases, the rate of photosynthesis will decline. And the main enzyme associated with photosynthesis is rubisco. Now next one, is green light most or least useful in photosynthesis? The answer, it is least useful in photosynthesis. Plants does not use the green light. They may be using the light between 400 to 700 nanometer wavelength, that is visible light. In that VIBGYOR, they will never use green light. Actually, it is reflected by the plant. The plant is actually not absorbing the green light. Now, write the equation for photosynthesis. So in photosynthesis, 6 carbon dioxide and 12 water molecule is actually used in presence of sunlight and chlorophyll. It is used in presence of sunlight and chlorophyll. Here you should understand, carbon dioxide is actually getting reduced. In photosynthesis, carbon dioxide is getting reduced as what? C6H12O6. So what is the product formed? Glucose. Where you can see water undergo oxidation, and this will be releasing out 6 oxygen, and here 6 water molecules also will be coming. So this is the equation for photosynthesis. Now next is the photosynthesis. If it is asked for 1 mark and all, you can write about it. It is the process by which green plants prepare food. Carbon dioxide and water is combining to form carbohydrate. Byproduct is oxygen, etc. But 2 marks, etc. when it is coming, you have to write about 2 reactions. One is light reaction that is occurring in the grana of chloroplast, and the other is dark reaction. Dark reaction, when you are writing, you should write it is taking place in the stroma of chloroplast. In the light reaction, the light energy is converted into chemical energy, and the main pigment that is present here is chlorophyll. Using that only they trap the light energy and they will be converting ADP and P into ATP, as well as they will convert NADP plus to NADPH. So formation of this chemical energy is actually done by splitting of water. So here there is splitting of water that is taking place, which will release electrons, H plus and oxygen. So this process only we call it as what? Photolysis. And it is taking place in the grana. Energy that is released will be used in the stroma for the dark reaction, where you can see the carbon dioxide will be converted into glucose. So this is the product of photosynthesis. So glucose is the main product of photosynthesis. Hope you got it. Now in the chloroplast, so in the mesophyll only photosynthesis is taking place. Hope you know the structure of a dicot leaf and all. Upper epidermis is coming, lower epidermis will be having the stomata, and in the lower epidermis there will be having the stomata with the guard cell, and the midrib of the leaf will be having the upper xylem and lower phloem, and it's getting covered by the bundle sheath. Then you also can see it will be having the palisade mesophyll. Like this, the palisade mesophylls will be coming, and here in between the air spaces there is spongy mesophyll also. In that the chloroplast is coming. So this chloroplast should actually receive water. So water will be coming from where? Water will be coming from the xylem. And second, they also need what? Carbon dioxide. That carbon dioxide from the atmospheric air. Like that, carbon dioxide and water will be reaching the chloroplast. So in the chloroplast only light reaction is occurring. In that you can see the light and dark reactions will occur. Finally, the food that is produced is glucose. Now one mesophyll, let me take out and draw. So if I am taking one mesophyll, in the chloroplast, the food that is coming out is what? The food that is coming out is glucose. So this is a mesophyll, and this is chloroplast in a mesophyll. If it is for storage, they will join all the glucose and it will be turning into a polysaccharide, and the polysaccharide that is formed is starch. But if it is for transport, the glucose will be joining with fructose in order to form what? In order to form sucrose, which is loaded into the phloem. Hope you are getting it. Now understand, from the chloroplast of mesophyll or from the mesophyll, the food is loaded into what? Phloem, and the transport form of sugar in the plant is sucrose. So that's all about the points associated with photosynthesis. Now experiments also you should try to recollect. Light is essential for photosynthesis, carbon dioxide is essential for photosynthesis, or the chlorophyll is essential for photosynthesis. So many experiments are there. Try to recollect that also. So the starch detection test using iodine solution, that also try to recollect. First of all, you have to take a test tube, put a leaf in that in boiling water. So what happens after that is transfer it into another test tube which contain alcohol. So you have to put it in a test tube which contain alcohol, then put it in the boiling water bath. After that you have to boil it nicely. Then put this leaf in a watch glass and put some iodine solution. So when starch is present, this leaf will be turning into which color? The leaf will be turning into blue-black color. So this is the experiment to show the presence of starch after photosynthesis. Now based on this only remaining experiments are coming. Sunlight is essential for photosynthesis. What we have to do in that experiment to show sunlight is essential for photosynthesis? Take a potted plant, keep it in dark room for how many days? 2 to 3 days. After that, put it in sunlight. So you have to keep the plant for 2 to 3 days in a dark room. The purpose is de-starching the plant. The purpose is de-starching the plant. After that, put the plant in sunlight. When you're putting the plant in sunlight, keep a black strip on that. Keep a black strip on one leaf on either side. After keeping it for 8 hours, pluck out this leaf, then perform the iodine test. When you are performing the iodine test, the region which was covered by black strip, it won't be turning blue-black. Remaining regions will be turning blue-black. It shows that light is essential for photosynthesis. In the next experiment, carbon dioxide is essential for photosynthesis. Take the same procedure. First of all, take a potted plant, keep it in a dark room for 2 to 3 days. So the purpose of keeping it in a dark room for 2 to 3 days is what? Destarching the plant. After destarching the plant, keep the plant in a bell jar. In the bell jar, you have to keep what? KOH. This KOH will be uptaking all the carbon dioxide. This plant will not get any carbon dioxide, but they will be getting the water as well as they will be getting sunlight, everything except CO2. Now pluck out a leaf and perform the iodine test. You won't be getting blue-black color. It shows that carbon dioxide is essential for photosynthesis. And in the next experiment, chlorophyll is essential for photosynthesis. Take a variegated leaf. Variegated leaf will be having chlorophyll only at some location. Now perform the iodine test. You can see only the chlorophyll containing region will be turning blue-black. Remaining regions will not be turning blue-black. It shows that chlorophyll is essential for photosynthesis. So with that, all the topic associated with photosynthesis is over. Now we are going to the next question. Define the term nutrition and nutrients. List two difference between holozoic and saprophytic nutrition. Give two example of each of these two types of nutrition. So understand nutrition, the process by which an organism acquire food from the external environment. That only we call it as nutrition, and that they are taking in is the nutrients. That only they will break it and they will use it for energy production. And two types of nutrition, holozoic and saprophytic. We are holozoic, amoeba is holozoic. They engulf and digest complex food particle followed by its absorption, assimilation and all. That is holozoic mode of nutrition. But in saprophytic, like fungus, you can see the digestion is outside the body. They release enzyme on this organic material or food. After digesting, they absorb the nutrients into the body. That is actually called as saprophytic mode of nutrition. Example of saprophytic mode of nutrition is fungi, mushrooms and all. Even some bacteria, yeast, etc. You can see it is saprophytic. This is also a question that you can expect. Holozoic as well as saprophytic mode of nutrition. Now parasitic also try to remember. Organism growing on the body of a host and uptaking nutrients from the host. That is actually called as parasitic mode of nutrition. If it is inside the body of the host, it is called endoparasite. Outside the body, it is called ectoparasite. Tapeworm. Tapeworm is an example. Ascaris. All these are example of endoparasite. Whereas cuscuta, a plant, as well as the lice, ticks, all these are example of ectoparasite. Now this is an expected question for the exam, that is the nutrition in amoeba, holozoic only. If you are getting it for the exam, you should write the 5 steps that is coming here. Ingestion, digestion, absorption, assimilation, egestion. Amoeba will be engulfing complex food particle using a finger-like projection that is called as pseudopodia. And they will engulf the complex food particle in order to form a food vacuole. That is the first step. So you should write about ingestion process. In that, write pseudopodia, food vacuole. Second step is digestion. Into this food vacuole, digestive enzymes are actually released and they break the complex food particle into simple form, that is digestion. In the next step, you can see the digested food particles are taken into the cytoplasm from that vacuole. That is actually called absorption. And after that, you can see absorbed food particles are used for metabolic activity, that is called assimilation. Then undigested food particle, what is left, is removed out of the body, that is called egestion. So these 5 steps you should write when you are getting to write about nutrition in amoeba. Now next one is describe the glands involved in digestive system. Name the correct substrate for the following enzymes. So which all glands are actually coming in the digestive system? You have to write about salivary gland that is coming in the buccal cavity. Then second, you can see liver is located, and in the stomach there is gastric gland, and in the small intestine there is intestinal gland, as well as the pancreas is also opening. So four things you should write: salivary gland in the buccal cavity, gastric gland in the stomach, liver and pancreas opening into which area? Liver and pancreas is opening into the duodenum part of the small intestine. Very good. Keep on commenting. I will be rushing like this. You have to keep on listening. Try to recollect. You have all the idea. Just try to recap it. That's all. Okay, Rahul Vijay. I'm moving now. Now, name the correct substrate for the following enzyme. Trypsin. Trypsin is an enzyme released in the pancreatic juice. It is associated with digestion of proteins. Second, amylase. It's an enzyme that is present in the salivary juice as well as pancreatic juice. There is salivary amylase and pancreatic amylase. It helps in digestion of starch. Then next one, pepsin. Protein digesting enzyme is pepsin. Then lipid digesting enzyme is lipase. So I have given a chart that is showing the digestion and all. So before explaining or discussing this, let's have a rapid fire of all the digestion that is taking place. Very easily you can remember it, learn it separately. So this is the digestive system. You may be knowing about the diagram and all. Buccal cavity, esophagus, then comes the stomach. Then from the stomach there is which structure? Small intestine, and where there is duodenum, jejunum and ileum. Then comes the which area? Then comes the next region, that is the large intestine, starting with the cecum, then the colon. There is ascending colon, transverse colon, descending colon, then rectum and anus. Like that is the structure of the alimentary canal, starting from the mouth, ending with the anus. In between, sphincters are also coming. That will prevent backflow of food. Here there is gastroesophageal sphincter. And here you can see cardiac sphincter between the stomach and small intestine. And here there is ileocecal valve. And here there is anal sphincter. Like that, sphincters are actually coming. Now, let me tell about the digestion. Very simple. Digestion of starch. You can learn it very easily. What you should know is starch is a polymer of what? Starch is a polymer of glucose. So like this, many glucose is actually joining in order to form the starch. So how the starch is actually getting digested? Here you can see this glucose will be broken down in the in the mouth by salivary amylase. I'm putting the flow chart. You should convert it into sentence when you are getting it for the exam. So digestion of starch occurs in buccal cavity. It is done by salivary amylase that is present in salivary juice that is secreted by salivary gland. Like this, you should convert it into sentence. Here what happens is the bond is broken between the glucose, 2 units of glucose. The bond is getting broken. This 2 units of glucose, this is the simplified one. You should take it down if possible. Then convert it into sentence only. This 2 units of glucose is called as maltose. So this is the digestion of starch that is occurring in your buccal cavity. If starch is not digested in your mouth, it will be digested in the small intestine. In the small intestine, there is release of pancreatic juice. Pancreatic juice contains the next enzyme, that is pancreatic amylase. It will be having what? Pancreatic amylase. They also do the same. After that only, this is digested by the next enzyme, maltase. This is an enzyme that is present in intestinal juice, present in intestinal gland. This will digest this 2 units of glucose into glucose. Like this, you can see glucose will be formed. Hope you understood what is digestion. Breaking of complex food particle into simple absorbable form only, we call it as digestion. So here what happens next is this glucose will be absorbed into the villi. So in the villi, you know, there are blood capillary. So into that blood capillaries in the villi only, this glucose will be absorbed. So digestion of starch is complete. Hope you got an idea. So starch is a polymer of glucose, a chain of glucose. First it is broken down into 2,2-glucose maltose, then into glucose, then absorbed into the blood. Clear? Yes. Lipase and all, it's not coming here. It's digestion of starch only, I explained. Now I am moving to the next one, that is digestion of protein. Very simple. Proteins are made up of amino acid. I am drawing different shape because different type of amino acids are actually joining to form a protein. This protein you can see, first it is digested by pepsin. Pepsin is actually formed by pepsinogen, and it happens when HCl is secreted. So pepsinogen and this HCl is present in the gastric juice secreted by gastric gland. So digestion of protein happens first in the stomach, where you can see they are broken down into smaller fragments and all. They are broken down into smaller fragments of protein. So this is a long polypeptide. This is a long polypeptide. It is broken down into short fragments by pepsin. Then action of HCl also you should learn. They are actually activating pepsinogen into pepsin. They also kills the germs. These are the functions of HCl. Then when this is coming into the small intestine, in the small intestine you should understand they are acted upon by which enzyme? Trypsin, which is present in the pancreatic juice secreted by the pancreas. Now they will break them into 2 units of amino acid. The 2 units of amino acids is actually called dipeptide, or amino acids are also produced. So like this, 2 units of amino acids will be coming. 2 units of amino acid is called dipeptides. Final digestion is by dipeptidase enzyme, which is present in the intestinal juice. And they will be breaking it into what? They will be breaking it into amino acid. These amino acids are uptaken by which part? Villi itself. So in the villi, into the blood capillaries only, these amino acids are actually getting absorbed. Hope you understood digestion of protein. Don't draw this for the exam, write only. So where what is happening and all, shortcut hope you have got. Shall I proceed? Now next is digestion of fats, one expected area. Large fat globules are broken down into smaller fat droplets mainly by bile. Bile is actually released in the small intestine by, in the small intestine bile is secreted by gallbladder, and actually the bile is produced in liver. This process only we call it as, what is the process called? The process is called emulsification. After emulsification, they are acted upon by which enzyme? Lipase enzyme. Either the pancreatic lipase or the intestinal lipase that is produced by the pancreas will be acting. They will break this small droplets. So large fat droplets. So what is emulsification? Breaking of large fat globules into small fat droplets. Only we call it as emulsification. Further you can see them broken into glycerol and fatty acid. Now they are getting absorbed into which part? They are getting absorbed into which part of the villi? In the villi, one more structure is coming, that is lymphatic vessel. Other than blood capillary, you should also remember there is lymphatic vessel. Into the lymphatic vessels only it is absorbed. So function of villi and all questions can be there, or how the small intestine is getting arranged to absorb the food particle. The answer is they have finger-like projection called villi. On the villi again there are so many structures called microvilli. It increases the surface area for absorbing the food particle. And in the villi, the digested lipids are absorbed into lymphatic vessel. digested carbohydrate and protein is absorbed into blood capillary. So that's all. Now, why does absorption of digested food occur mainly in small intestine? The answer is this, villi. They have finger-like projection called as villi. In that, microvilli is also present. It increases surface area for absorption of food particle. Inside that, there is blood capillary, which will uptake digested carbohydrate and protein, whereas digested lipids are uptaken into lymphatic vessel or lacteal. Now, what substance are contained in gastric juice? Already we discussed. Gastric juice contain the pepsinogen and HCl. HCl will be doing what? They will be converting pepsinogen into pepsin. They also kill the germs. Now, write the function of the following in human alimentary canal. Saliva. They contain salivary amylase as well as antibacterial enzyme. So, saliva help in digestion of starch. Then HCl in the stomach. It will kill the germs as well as activate pepsinogen into pepsin. Then bile juice. Bile will be neutralizing the acidic food that is coming from the stomach into small intestine. Second, bile is also helping in emulsification, breaking down of large fat globules into simple fat droplets. That process only we call it as emulsification. Then what is the function of villi? Finger-like projection that increase the surface area for absorbing the food particle. Inside the villi, blood capillary absorb digested carbohydrate as well as the digested protein, whereas lacteal absorb digested lipids. Hope you got it. Now, next one. How do the guard cell regulate opening and closing of stomata? Guard cell structure you should be knowing. In that, opening and closing is with the help of entry and exit of water. Whenever water is entering into this guard cell from the epidermal cell or the subsidiary cell, this guard cell will become turgid and open. But whenever water is actually exiting, out of the guard cell will become flaccid. When it is becoming flaccid, it closes. So entry of water, guard cell turgid and open. Exit of water, you can see the guard cell will become flaccid and close. Don't write shrinking and all, that is wrong. Actually, it is becoming flaccid. When it becomes turgid, it is opening. When it becomes flaccid, it is closing. This is what you should remember. Okay, very good. Now, next one. What is translocation? Why it is essential in plants? Transport by xylem and phloem. They transport bulk of material from one part of the plant to another. That is actually called translocation. Especially xylem, you can see they transport water and minerals from the root to the shoot. Whereas food is transported by the phloem from leaf to all other parts of the plant which is not able to perform photosynthesis. That is actually called translocation. So it is essential for transporting water, minerals and food particle, and it is done by xylem and phloem. Then where do the substance in plants reach as a result of translocation? As a result of translocation, you can see water and minerals will be reaching the shoot. Food particles will be reaching different parts of the plant that is unable to perform photosynthesis from the leaf. Now, next one. Name the energy currency involved in living organism when and where it is produced. Energy currency that is produced in living organism is ATP, adenosine triphosphate. It is produced mainly in mitochondria. Then what happens to the rate of breathing during vigorous exercise? When you actually perform vigorous exercise, all your cells require a lot of energy. For energy production, they need oxygen because it is aerobic respiration. So your breathing rate will keep on increasing. So breathing rate will keep on increasing when you are doing vigorous exercise because there should be a good supply of oxygen to all the cells to produce a lot of energy in aerobic respiration. Are you getting it? Yes, increase in breathing rate. Now next one, describe aerobic respiration. So aerobic and anaerobic respiration, this chart you should be knowing. So here in the cell you should understand the glucose, the 6-carbon glucose is first broken down into a 2 units of 3 carbon containing pyruvic acid, 2 units of 3 carbon containing pyruvate. This process is called as glycolysis. In aerobic respiration, pyruvate will be going to the next cell organelle, that is mitochondria. In the mitochondria, this 3 carbon containing 2 units of pyruvic acid or pyruvate, here you can see in presence of oxygen, they are broken down into carbon dioxide, water and energy, especially 38 ATP molecule. This is aerobic respiration. This is called as aerobic respiration. So aerobic respiration, draw a chart and write it. And what is the net gain of energy from 1 glucose? 38 ATP. But in anaerobic respiration, in your muscles and all, when there is no enough supply of oxygen, this same pyruvate will not be transported into mitochondria. In the cytoplasm, you can see they will be getting converted into what? They will be getting converted into lactic acid, 2 units of lactic acid. But in the yeast cell, in anaerobic condition, so here 2 ATP is produced. In yeast cell, in anaerobic condition, you can see 2 units of ethanol, and you can see there is 2 carbon dioxide also that is released in this process. So yeast produce ethanol, and understand anaerobic respiration is completed in cytoplasm. Aerobic respiration is completed in cytoplasm and mitochondria. Sometimes the difference between aerobic and anaerobic can be asked. Anaerobic respiration, energy production is less, only 2 ATP is coming. Aerobic respiration, energy production is very high, 38 ATP is coming. Now, next one, explain the process of breathing. So here you can see in breathing, 2 things you have to actually get, like inhalation, exhalation. In inhalation, you should understand ribs will be moving forward and the diaphragm will be moving downward, 2 things. So when a person is inhaling, the ribs move downward, the diaphragm move downward, ribs move forward. So space inside the chest cavity will increase. When the space inside is increasing, what will happen? When the space inside is increasing, the pressure inside will decrease. So when diaphragm move downward, ribs move forward, the space is increasing, pressure is decreasing. You can see the air will be moving from outside to inside. This process only we call it as inhalation. The process is called inhalation. Is it clear? Now next one. Yeah. Next is just opposite, exhalation. When you are getting right, just opposite. That means diaphragm will move upward, ribs move backward, and the space inside is decrease. And what happens to the pressure? The pressure inside will increase. Then you can see air move outward. That is actually exhalation. So inhalation, exhalation, these 2 points only. Then when you are exhaling, CO2 is coming out. You know the experiment to show that. Take some lime water and breathe out. It will turn milky. It shows that carbon dioxide only we are breathing out. Now next one, describe the structure of human kidney and define excretion. So what is excretion? Here you can see it is the removal of metabolic waste particles from the body. That process only we call it as excretion. Don't simply write removal of waste particle. You have to keep this in mind when you are writing it for the exam. Please make sure you are writing it as removal of toxic metabolic waste particles from the body, which when accumulating can be toxic to the body. That is what we call it as excretion. And excretory organs, examples and product if it is asked, first you can write lungs. Lungs is an excretory organ. The product is carbon dioxide. Kidney is an excretory organ. Liver is an excretory organ. Skin is an excretory organ. Then name the basic filtration unit that is present in kidney. The structural and functional unit of filtration in kidney is nephrons. Then draw the excretory system in human beings and label the following organs. Excretory system which perform the following function. Forming urine is actually done by the kidney. You have to draw it. Then long tube-like structure, that is ureter. Then store urine is the urinary bladder. So let me draw the structure of a human kidney. So when you are drawing, you have to draw like this. There should be, then here a pair of ureters should come, that is placed obliquely downwards. It is placed obliquely downward. Then there should be urinary bladder. There should be a urinary bladder and urethra. This much structure should be coming. Then you can see it will be having a renal artery that is entering. So blood for filtration is brought in the kidney by renal artery, and purified blood is taken away by the renal vein. Purified blood is taken away from the kidney by the renal vein. Hope you got this structure. You should label it also. Oh, Mriduvand Raghavan. It mostly won't come for drawing. I think you are putting the question paper. Then let me check. So here next is about the glomerular filtration. So in the nephrons you can see the glomerular filtration. Okay, Ishvi. So here glomerular filtration in the nephron. 3 steps you should remember. Coming to urine formation, first step is glomerular filtration. Then second step, glomerular filtration is there. In glomerular filtration, blood for filtration will be coming here. And it will be passing through the glomerulus. It will be passing through the glomerulus. So under high pressure when the blood is passing, you can see so many things will be coming into the Bowman's capsule. It includes useful particles as well as waste particle. So understand, there will be useful particle as well as waste particles that are coming here. In that, useful particles are absorbed back into the blood. Can you understand? This process is called tubular reabsorption. What is it called? Tubular reabsorption. So urine formation step it is asked. 3 steps you should write. Simple only. First is glomerular filtration. Blood flows through the glomerulus under high pressure. In that, useful particles and waste particles will be coming. In that, useful particles again go back into the blood. That process will happen in the PCT, DCT, etc. That is tubular reabsorption. Then those waste particle which was not filtered here, again it is put back at different location in the nephron. This is called tubular secretion. The process is called tubular secretion. That's all about. Okay, ultrafiltration, tubular reabsorption, tubular secretion. One line. You can write it. So here hope you got it. Shall I move to the next one? Now next one is hemodialysis. Hemodialysis is done for a person who has undergone kidney failure. In his body, the uric acid will keep on accumulating. So what can be done is, the blood is taken from the person and it is passed through an instrument. So which instrument it is actually getting passed? You can see it will be taken from the person and it is pumped into a dialysing machine. In the dialysing machine, when this blood is actually passing, you should understand the waste from the blood will pass into the dialysing fluid. The dialysing fluid, the concentration is same as the blood, except it won't be having any waste. So waste particle in the blood will diffuse into the dialysing fluid and the purified blood is put back into the person. This is hemodialysis. This is hemodialysis. Sir, how is liver an excretory organ? Liver is an excretory organ because liver will be detoxifying many things in our body. Drugs that you are actually consuming, even the urea that is filtered from the blood in the kidney, that is produced in the liver. Nitrogenous waste particles that are produced in the liver will be detoxified. Nitrogenous waste particles that are formed from protein. It's actually ammonia which is converted into urea in the liver. Then only from the liver this urea is taken to the kidney where it is filtered out. So liver is also an excretory organ. Hope you got it. Yes. Question was asked by... Okay, shall I proceed? Fatima was asking the question. Okay, so a person who actually have renal failure, they can actually go for two things, either a transplantation or a hemodialysis. I am moving to the next one. The difference between blood and lymph. You know that the lymph is actually formed from the blood itself when it is oozing out of the capillary. The composition of lymph, if you take, it is same as that of the plasma, but the protein's concentration as well as the lymphocyte, if you are taking, it will be there in the lymph. But it won't be having any blood cells and all other than this lymphocyte. Then lymph, you can expect some questions. So let me tell about lymph. In between the blood and the cells, so if this is the blood and if this is the cells that are coming, you should understand lymph is located here. So many things will be passing from blood to the cells and from cell to the blood via lymph only, especially oxygen, carbon dioxide, nutrients, as well as the hormones. All these will be passing from blood to cell and cell to blood via lymph. So it is actually a fluid that is also derived from the blood itself. Hope you got it. So here the difference you should remember, it is red in color and it contains RBC. Lymphocytes are present, nutritive substance are more, oxygen is more, and it also contains metabolic waste also. Soluble proteins are present, fibrinogen is present, that is helping in blood clotting. You know what is blood clotting? Whenever there is a cut or wound in the body, suddenly at that location, fibrinogen will get converted into fibrin, where the blood cells are getting trapped in order to form the blood clot. Then lymph, it is colorless. RBC is absent, lymphocytes are actually present, nutritive, oxygen is relatively less, both are more than in blood, insoluble proteins are more than soluble one, fibrinogen is present in less amount. So this much is the difference between the blood and the lymph. Now next is, mention any two components of the blood. So blood, if you are taking, there is plasma as well as the formed elements. Plasma is the fluid part which contain 90% water, 7 to 8% protein like albumin, globulin, fibrinogen. And the formed elements include RBC, WBC and platelets. RBC is associated with transport of gases, WBC associated with defense mechanism, blood platelets will be associated with clotting. Then trace the movement of oxygenated blood in the body. So here you should be remembering double circulation. Easily you can learn double circulation. You are having a 4-chambered heart with right atria, right ventricle, left atria, left ventricle. So from the left ventricle, let me start from the cell. So this diagram is the simplified diagram. From the cells you should understand the deoxygenated blood will be first entering into the capillaries. And from the capillary, the deoxygenated blood next enter into the smallest vein, that is called venule. Then it will be entering into little bit largest vein. What is that called as? That is actually the normal veins, which will be entering into the largest vein. The largest vein that is coming is vena cava. Then from here, deoxygenated blood will be moving into the right ventricle. From the right ventricle, so here a tricuspid valve is coming. From here, the deoxygenated blood will be going to the lungs. The deoxygenated blood will be going to the lungs, where you can see carbon dioxide is removed out, oxygen is taken in. And from the lungs you can see this oxygenated blood will be brought to the left atria by the pulmonary vein. So this is actually done by pulmonary artery, and here it is pulmonary vein. Oxygenated blood will pass through the left ventricle and it is taken out by the aorta, which will join the smallest artery, that will join the arteriole, then the capillary. From there you can see oxygen will go to the cells. So here same blood is rotating through the heart. How many times? Twice. So blood going to the right side, go to the lungs and return to left side and come back. This is called double circulation, and expected area is double circulation. So what is the significance of double circulation? Significance of double circulation, you should try to remember there is a good separation of oxygenated and deoxygenated blood in double circulation. So the blood that is coming in right side go to the lungs, there you can see they are getting oxygenated, come to the left side and go to the cell. So here they are increasing the efficiency. They are increasing the efficiency of oxygen supply to the cells. That is the point you should remember. So drawing heart in exam is very hard. Do you have any trick to draw? Very simple. You can easily draw the heart. If it is coming, first draw like this, the right atria, then here like this, then keep this in mind. First draw this much only regarding the heart. Then what you should do is, from this side you should draw, from this side you should draw the pulmonary artery towards this side. Then from this side you should draw the aorta. Can you understand? So this is the right atria, and here you should draw the vena cava, superior vena cava, inferior vena cava, then draw the muscle. So this is the rough structure. First give a gap in the middle, draw the two things upward. That is the simplest way. Brain diagram and all, it is simple. You can easily draw if it is coming. Don't think that it is complicated. Yeah. So this is the simplest one for understanding. Hope you got it. Then you should remember the left ventricle will be having thick muscles. Left ventricles will be having thick muscles. So this is right atria, right ventricle, left atria, left ventricle. So I am drawing it very fast. You can also do it. Then here you should be able to draw what? Pulmonary vein. Here you should be able to draw the one that is the vena cava. Then here pulmonary artery. Then this is the aorta. Are you getting it? That's it. Simple. Yeah. So write the functions of valves present between atria and ventricle. The valve that is coming between right atria and right ventricle is tricuspid valve. Between left atria, left ventricle is bicuspid. It will prevent the backflow of blood from atria to ventricle. That's all. Then structural difference between composition of artery and vein. You can expect this question, the difference between artery, vein and capillary. Artery, veins and capillaries, if you are taking, arteries are very thick walled because it has to pump the blood under high pressure, or blood will be taken through the arteries under high pressure. Whereas this one, if you take the veins, it is thin walled. Then if you take the capillary, one cell thickness, and remember like this, arteries always take blood away from the heart. Arteries always take blood away from the heart, and veins always bring blood towards the heart. Veins always bring blood towards the heart. Like that you try to remember. Then the arteries usually carry oxygenated blood except which one? Pulmonary artery. Veins always carry deoxygenated blood except pulmonary vein. Then capillaries are one cell thick. It is the site of exchange of gases. This much you should try to recollect. Hope you got it. Now also the difference between this one, single circulation. In fishes and all you can see single circulation. Veins are visible but arteries are located inside. Yes. So main points you write. That is enough. Then arteries are deeply ingested. Yeah, it is coming deep inside and all. Now next one. Okay, that's all about the question from circulation. Single circulation also you can expect some question. Single circulation is seen in fishes where you can see only one one atria, one ventricle. From the cells, the deoxygenated blood is going to the heart. From there, it is going to the gills. Then in the gills, it will be diffusing out. And here you can see oxygen is taken in, oxygenated blood directly coming to the cell. It is not going to the heart and returning, it is directly going to the cell. This type of circulation is called single circulation. Easily you can remember it and draw it and you can write it also. That's all. Now let's start with the next chapter. What is synapse? So the gap or junction coming between two neurons are actually called as synapse. So it is the junction between a presynaptic neuron and a postsynaptic neuron where chemical transmission of nerve impulse is taking place. So 2 marks, 3 marks, you should write this much. Don't just write gap between two neurons. If it is 2 marks and all, write like this itself. It's a gap coming between presynaptic and postsynaptic neuron where chemical transmission of nerve impulse is taking place. Electrical transmission take place inside the neuron, whereas chemical transmission occurs in the synapse. Then label and mark the parts of a neuron. Already you know, this part of the neuron is the cell body or cyton. The primary branch is dendron, secondary is dendrite, then the longest one is axon, which is covered by the Schwann-cell and the myelin sheath. And at the end there is axon terminal. At the end there is a synaptic knob also. That is the structure of a neuron. So here name one gustatory receptor and one olfactory receptor present in the human being. Gustatory receptors include all the tissue that is for taste that is coming on the tongue. Olfactory receptor include all the tissues coming inside the nose that is for receiving which stimulus, smell. Then write A and B in the given flow chart. A actually represents from the dendrite. Here you can see the nerve impulse will be going to where? The nerve impulse will be going to the cell body. From the cell body, the nerve impulse is taken by axon. Then it will be reaching the end point of the neuron. Very good. So many comments are coming. Nabiha. Okay, good. Then next one. How is a reflex arc formed? Explain the pathway of reflex action. Give 2 examples. This you can expect. Reflex action you should understand. There is a spontaneous reaction produced by your nervous system in response to a stimulus. That is what we call it as reflex action. In reflex action, there is a receptor which will receive the stimulus. It can be the touch receptor in your skin, or it can be photoreceptor in your eye, phonoreceptor in your ear, whatever it is. After receiving the stimulus, you can see the nerve impulse is carried to the spinal cord. So usually when you touch something and all, nerve impulse will pass like this, go to the spinal cord, then the brain return back. You produce the response and all. But here you can see the nerve impulse is carried by sensory neuron to the spinal cord, where an interneuron will give the message to a motor neuron, give it to effector, and you produce the response like you are touching a hot object. When you touch it, from the receptor you can see the nerve impulse go to your spinal cord. Then from the spinal cord, interneuron will give message to motor neuron. The message will come back to your effector, that is muscle. Suddenly you will push the hand off. That is actually reflex action. And the pathway of reflex action is called reflex arc. 2 examples, touching a hot object, pinprick. All these are examples of reflex action. Okay, axon end, Venkatesh. Axon end, synaptic knob will have synaptic vesicle. Synaptic vesicle release a chemical called neurotransmitter. Neurotransmitter from the presynaptic neuron go to the synapse, passes through the synapse, attached to the postsynaptic neuron, generating a nerve impulse. So in the synapse, nerve impulse transmission is with the help of a chemical structure that is called as neurotransmitter. Relay neuron or interneuron is the neuron that connects sensory neuron with the motor neuron in the spinal cord. Shall I proceed? Fatima, got it? The neuron that is connecting the sensory neuron and motor neuron. Yeah, that's it. Now next one. Which part of the brain is associated with? So many were asking, can we draw brain and all? It's easy. First you draw a simplified cerebrum. Like this you can draw a cerebrum, cerebral hemisphere and all. Then this is the part of forebrain. Next part you can see there is thalamus. Next part of the brain you can draw it as thalamus. Then the next part you can see there is hypothalamus with the pituitary gland. This much is actually coming in the forebrain. Then the second part that you should draw is the midbrain. So red color, what I am putting is the midbrain. After the midbrain you can see there will be a structure that is pons. This is the pons region. Then the next region that comes is the medulla. Next region that comes is the medulla. Then here you can see from the pons comes the second largest part of the brain. What is the second largest part of the brain? Cerebellum. So I am able to give rough picture about the structures and all. So the site that is actually controlling posture, equilibrium of the body and all, cerebellum is the second largest part of the brain, which is associated with your posture, movement, balance and all. So if a person is drinking alcohol and all, main part of the brain that is affected, so that he is losing the balance, etc., that is cerebellum. Blinking, reflex, etc., is coming in the midbrain, that I will tell. Then regulation of breathing is coming in pons region. Posture and movement, that will be coming in this cerebellum. Memory, vision, hearing, etc., that is cerebrum. Visual and auditory reflex is in midbrain. Hunger, thirst, etc., is in hypothalamus. Hope you got it. Shall I proceed? So these are the different parts of the brain. Now next is hormone. Metabolism of carbohydrate, fats, protein, etc. It is associated with which hormone? Thyroxine. Balancing calcium and phosphate. Come and fast. Let me check who all knows this answer. B. I am leaving. Blood pressure, which we can write is as either adrenaline or aldosterone. They can actually regulate the blood pressure. Water and electrolyte balance, ADH, antidiuretic hormone, or it is vasopressin. Anyone? Second one, balance of calcium and phosphate. Can you comment? Calcium and phosphate, it's not ADH, Rahul. Let's see who will comment it first. So thyroid will be actually producing which hormone? Thyroxine. It's located in this region. Location you should remember. Then pituitary gland. Name the hormone secreted by following gland. Pituitary gland will be producing many hormones like TSH, thyroid stimulating hormone, follicular stimulating hormone, luteinizing hormone. Then pancreas, the endocrine part secrete two hormones. One is insulin and the other is glucagon. Very good. Who commented first? Let me tell. Sam Ron. Sam Ron made the first comment to this answer. Parathyroid gland will be producing parath hormone that will control the calcium and phosphate. So increasing the level of blood calcium and phosphate is done by parath hormone, decreasing calcitonin. Now feedback mechanism of hormonal regulation, taking an example of insulin. So insulin function, let's discuss. So understand, in your blood, if the glucose level is increasing, suddenly, if the glucose level is increasing, suddenly you can see the endocrine part of pancreas will produce what? Insulin. As a part of that, you can see into the liver, this glucose will be uptaken and all the glucose will be joined in the liver in order to form what? In order to form glycogen. Can you understand? So slowly all these glucose will be going into the liver and they will get converted into glycogen. Second, the surrounding cells also will start uptaking glucose. Surrounding cells also will start uptaking glucose. So insulin, when action is asked, two things you should write. When the blood glucose level is going more than normal, suddenly pancreas endocrine part will release the insulin that decrease the blood glucose level in two ways. One is cellular uptake of glucose. Second, converting glucose into glycogen in the liver. And if it is going too much down, just opposite. Just opposite means which hormone is produced? Name the hormone that is going to decrease the blood glucose level. Blood glucose level can be increased by which hormone? Decreased by insulin, increased by which hormone? It is actually increased by glucagon. So glucagon, what they will do is, they will start releasing this glucose from glycogen back into the blood. So from the glycogen, the glucose is broken and put back into the blood. That is actually done by. So first answer was given by Sahran. Very good. That is glucagon. Glucagon will increase the blood glucose level. Two-way, breaking glycogen in the liver, releasing glucose into the blood. It also prevents cells from uptaking glucose for a while so that the blood glucose level will increase. So this is feedback mechanism for increasing and decreasing the level of glucose. So hope you got this much question. Now location of glands and all, you should remember. The head is having pineal gland, pituitary gland, and the neck region, thyroid and parathyroid, chest region, thymus, that produce the WBC, that is the T lymphocyte. Then adrenal gland located above the kidney, adrenaline, emergency hormone, pancreas. So all these are coming in abdomen. The thorax contain only thymus. The neck contain the thyroid and parathyroid. Then in female you can see in the pelvic region there is ovary. Males you can see outside the body there is testis. In that 3 glands are dual glands. Both endocrine and exocrine function is there. One is pancreas, second is testis, third is ovary. Exocrine part of pancreas release pancreatic juice, testis release sperm, ovary release ova. Endocrine part of pancreas release insulin glucagon, testis endocrine part release testosterone, and ovary the endocrine part is releasing estrogen and progesterone. So remember, they are actually the dual glands. They have both endocrine and exocrine function. Now next is about tropic movements and nastic movement. Growth dependent movement is called tropic movement. Independent movement is called as nastic movement. So tropic movement, explain with an example. You can write about phototropism, the bending of plants towards the direction of light. You know which hormone is associated with that. The hormone associated with that is which one? Auxin. Auxin is the main hormone associated with bending of plants towards the direction of light. Where you can see auxin move to the shaded area, and cells in that area will enlarge. That will make the plant to bend towards the direction of light. So growth dependent movement is tropic movement. Independent movement is nastic movement. So this one you know, thigmonasty. When I touch this plant, the leaves will suddenly close. So there is no growth in the plant, but there is movement. Like this, growth independent movements are actually called nastic movement. Thigmonasty in Mimosa pudica or touch me not plant. So hope you got it. Now next one. If ripened fruit is kept in a basket of raw fruits, then what will happen? That causes it. What can happen? Can you tell which hormone is actually associated here and what is going to happen? Let me check who is going to comment first and all. Very good. Venkatesh has made the first comment. Ethylene. Ethylene is the gaseous hormone released by ripening fruit. It will make the unripened fruit also to become ripened. So gaseous plant growth hormone is ethylene. Hope you got it. So function is ripening. Name the stress hormone in the plant. Next question, stress hormone in the plant. Who is going to comment first? Let's see who is going to comment first. Rahul, please comment first rather than commenting of others. Yes, abscisic acid. Okay, Sharon made the first answer. Abscisic acid is actually the stress hormone. The hormone that is produced in the plant in stressful condition. Stressful condition means when the temperature outside is very high, transpiration will increase in the plant. When transpiration is increasing, what will happen? The water in the plant will decrease. So suddenly what they will do is they produce the stress hormone abscisic acid. Then the stomata will close. So function, closure of stomata. Then they make the seed, bud, etc. to enter dormancy. Otherwise they have to spend a lot of energy. So dormancy of bud, dormancy of seed, abscission of leaf, abscission of ripened fruits, closure of stomata, all this happens to conserve energy. This is done by the stress hormone abscisic acid. Now next one, name the hormone associated with bending of plants towards the direction of light. Just now we discussed, if light is coming in a plant from this direction, auxin will be migrating to the shaded region. In shaded region, the cells will elongate. That will make the plant, so cells in this region when elongating and other side it is normal, that will make the plant to move towards the direction of light. So auxin is associated with thigmotropism as well as phototropism. You may be getting a question like this also. On a twig, if a plant is curling around, which hormone is associated? Here the stimulus is touch. It is thigmotropism only. where you can see wherever it is touching, auxin will move to opposite side. Cells in that region will elongate. That will make them to curl around the plant. So that is thigmotropism. Hope you got it. Now let me move to the next one. How does our body respond when adrenaline is secreted into the blood? You know about adrenaline. It's an emergency hormone. It is produced in our body in stress condition. When you are going for a fight, flight, or when you are feared of something, a lot of adrenaline will be rushing out. So changes occurring, you should remember, if you are going for a fight or if a dog is chasing you, what all things will happen? At that time you can see your heartbeat will increase and your breathing will increase because a lot of blood supply will be there to the muscle because you need a lot of energy. Your pupils will dilate. All these things can happen when adrenaline is rushing out. So it is an emergency hormone which is produced in three situations: fight, flight, and actually fight. So these are the plant growth hormone: auxin, gibberellin, cytokinin, ethylene, and abscisic acid. So just go through the points related to that. Now next one, next chapter, that is the how do organisms reproduce. Can you give the examples faster? Let me check the comment. Binary fission. Which all example you know about binary fission? In binary fission, you should remember the parent cell will be undergoing DNA replication as well as cell organelles duplication. First thing that happens is DNA replication and there is duplication of cell organelle. When you are writing, you should write the same. There is duplication of cell organelle. After this only you can see they will be undergoing karyokinesis. They will be undergoing karyokinesis in order to form two nucleus, and which is followed by cytokinesis. So there is nuclear division followed by cytoplasmic division to form two equal sized daughter cell. So here remember the parent cell's identity is lost. So binary fission example. Binary fission also remember it's found only in which organism? It's found only in unicellular organism. It's not found in multicellular organism. Amoeba, Paramecium, Euglena, all these are example of binary fission. In multiple fission you can see in the parent cell first there is repeated nuclear division. Around each nucleus cytoplasm also will be dividing in order to form many daughter cell. That is multiple fission. Example of multiple fission is Plasmodium. Then budding in yeast and hydra. Exogenous buds are produced. Buds can either detach or they can grow into a new individual or they can stay attached to the parent in yeast. So differentiate between binary fission in amoeba, budding in yeast. There can be question. In amoeba you should remember the parent cell's identity is lost during binary fission, but in budding in yeast only one daughter cell is produced. Parent's identity is not lost. That is the difference between binary fission in amoeba and budding in yeast. So these are all the examples. Then fragmentation. Example of fragmentation is filamentous algae. In algae and all you can see the long filament will be splitting into 2-3 pieces of fragment. Each piece or fragment can grow into a new individual. So fragmentation is observed in some fungi and filamentous algae like Spirogyra. Then planaria show high regeneration capacity. So why we don't have regeneration? Why the smaller organism have? Because we don't have specialized regenerative cells in our body. That is why if some organ is cut off, it won't be regrowing. But in this organism, you can see not only regrowth, they can produce an entirely new organism. So it's a method of reproduction in planaria. Then coming to fungi. Fungi will be having spore formation. Fungus will be having spore formation. So example of spore formation, hope you remember rhizopus. When you are actually drawing about rhizopus, remember they have root-like structure. The root-like structures that are coming in rhizopus is called as rhizoid. It is called rhizoid. The thread-like structure that is coming in a fungus is called as hyphae. At the tip of the hyphae, they will be producing sporangia. At the tip of the hyphae, they will be producing spore-containing structure that is called as sporangia. Inside the sporangia only, they will be producing the spores. They are actually called sporangiospore. They are actually called as sporangiospores. You should understand they will be breaking open and they will be releasing this sporangium outside, which when falling in the soil can actually grow into a new ones. Sir, then what is the difference between regeneration and binary fission as their parent identity is lost during reproduction? Regeneration, try to understand. What is the regeneration? Binary fission is unicellular. Regeneration's case also same only, but it is multicellular. That is the main difference. Shall I proceed? Venkatesh. Hydra regeneration is there. That is correct only. Hydra also regeneration is there. So the example of regeneration, you can write planaria and hydra, budding yeast and hydra, fragmentation, filamentous algae, fungi, etc. Okay, I am proceeding. Then the natural method of vegetative propagation, bryophyllum, leaf buds you should remember, they can fall off the plant, grow into a new one. Artificial method of vegetative propagation, grafting, layering, cutting. Then there is questions like what is the advantage of vegetative propagation and all. So advantages of vegetative propagation, we can use the vegetative propagation for growing those plants in which the flowering, fruiting, etc. will take a lot of time. Or else the plant which cannot climatize in a particular soil and all, vegetative propagation is the best method for multiplying. These are the importance or significance of vegetative propagation, artificial vegetative propagation. Further I am not telling, you know, cutting, stem cutting and all, or layering. Layering means you have to bend the branches under the soil after putting some scar. From the scar, root will be formed. You can cut and take it as a new plant. Or else grafting using a stalk and so on. So these are, even tissue culture is also a method of artificial vegetative propagation. And regarding bryophyllum, that is natural method of vegetative propagation. Now moving to the next question. This is an important question. You can expect example of unisexual and bisexual flower given in NCERT. Unisexual flower, papaya and watermelon. You know what is unisexual, bisexual. If a plant has both the sex organ in the same plant itself, that is bisexual. If only one sex organ is coming, either stamen containing flower alone or the plant has only pistil containing flower alone, then it is unisexual. So here example of plants with staminate or pistillate flowers are papaya and watermelon. In papaya and watermelon, you can say a plant will have either male flower only or female flower only. But bisexual flower with stamen as well as the pistil can be observed in hibiscus and mustard. So take down this example, you can expect this papaya, watermelon. Then identifying the following parts of a flower. Part that produce the pollen grain, which is the part that is producing the pollen grain. Stamen is the part that is producing the pollen grain. Then part that transfer the male gametes. The part that is actually transferring the male gamete is which one? The part of the flower which is transferring the male gamete is the pollen tube. That is carried through which region? It is carried through the style. Part that is sticky to trap the pollen grain, that is stigma. It is actually the stigma. Part that develop into the fruit. Ovary will be turning into the fruit. Ovule will be turning into the seed. So what is self-pollination? So self-pollination, if asked in the exam, you should write like this. Transfer of pollen grains from anther to stigma of a flower. From the anther to the stigma of a flower is called which pollination? Self-pollination. And if the pollens are transferred from anther to stigma of different flower, from the anther to the stigma of different flowers of different plants, then it is called as which pollination? Cross-pollination. Got it? So self-pollination and cross-pollination. Then structure of a typical flower can be asked for the exam. You should be able to do it very nicely. Drawing part, so many students were asking in the classes also how to do it. It's easy. You put the sketches correctly with a labeling and all. And don't expect for so much perfection and all in the exam time. You will lose a lot of time. So stalk portion of the flower is called what? Pedicel. Base portion of the flower to which it is attaching is called thalamus. Then you can see there is outermost whorl of a flower that is coming. Outermost whorl of a flower that is coming is called sepals. Then you should write the function. What is the function? Protection in bud stage. Protection of the flower in bud stage is the main function. Then you can see there is the beautiful and colorful part of a flower, that is actually the petals. The main function of the petal is what? Attraction of insect. Main function is attraction of pollinating agents. Then you can see there is the male reproductive part of a flower. The male reproductive part of the flower is stamen, which will be having a filament, and at the tip you can see they will be having anther, and inside the anther they will produce the pollen. Then at the center there is female reproductive part, that is actually the pistil or carpel. This pistil or carpel, if you are taking, it will be having a tip, that is the stigma. Then you can see there is a style and there is an ovary. Inside the ovary it will be having ovule. So that's all about the structure of a typical flower. When you are drawing it, describing it, start writing point wise. Next one, what are sexually transmitted diseases? List 2 viral and 2 bacterial STDs. So here, sexually transmitted diseases are a group of communicable disease, infectious disease, and that are transmitted by sexual contact from an infected person to a healthy person. So unprotected sex and all, when they are doing, there is chance of getting this. So here they can be bacterial, viral, protozoan, fungal, etc. Here the viral STDs example, AIDS and hepatitis. Then bacterial, syphilis and gonorrhea. Then give 2 reasons for avoiding this. Give 2 reasons for avoiding frequent pregnancy by women. Why they go for contraception? Why they avoid the frequent pregnancy? So here they are avoiding it due to the health issues and all. It has adverse effect on health. Second, it increased the rate of population of our country. And this can also have drastic impact on economy also. So that are the reasons they are actually planning for contraception. Yes, bacterial, syphilis. Yes, all answers are coming. Okay, then I am proceeding. Have you got it? Shall I proceed? Gonorrhea, bacterial only, caused by Neisseria gonorrhoeae. Syphilis, Treponema pallidum. Then if you want some more diseases, I will write. Herpes, herpes simplex virus, genital warts, human papilloma virus. Like that we can write so many, but this is enough. Now, suggest 3 contraceptive methods. This is also an expected area, contraceptive method. You can write about the barrier method, use of condoms and diaphragm. Second, you can write chemical method, use of pills and all. Third, you can write surgical method, that is vasectomy and tubectomy. Cutting and tying of vas difference only we call it as vasectomy. Cutting and tying of fallopian tubule is actually called tubectomy. Then you can also write placing of copper T in the uterus. That copper T will release so many copper ion that can make the sperm non-motile. So these are the different methods of contraception. This is also an expected question. So barrier method, that is using mechanical barrier so that sperm and ova will not come in contact, use of condom and diaphragm. Second is chemical method, using oral pills like progesterone pills are consumed. This progesterone pills if consumed, your hypothalamus will not release hormone that will make the anterior pituitary to release FSH and LH, which is associated with ovulation. So ovulation can be suspended if progesterone pills are taken. Then surgical method, cutting and tying of vas difference is called vasectomy. So sperm won't be reaching the semen. And cutting and tying of fallopian tubule. So in the oviduct there is no fertilization, that is tubectomy. Then IUD, intrauterine contraceptive device, where copper T is actually placed in the uterus. So this is also an expected area. The next one, list 2 reasons for the appearance of variation among the progeny of sexual reproduction. In sexual reproduction, you may be knowing half the number of gene is coming from father, half from mother. So surely the offsprings have a lot of dissimilarity. That only we call it as variation. Variation is good only if it is a favorable variation. That means it will help the organism to survive. So variations will help the organism to survive. If it is accumulating and if the organism look entirely different from parent, we can call it as a new species. So arrival of new species is by accumulation of variation. Now name the part marked A. So what is A? Pollen. B. Stigma. C. Pollen tube. Then D. It is the embryo sac in the ovule. In the embryo sac that is present in the ovule. Yeah, cross pollination, it is in different flowers only. Now you are asking the question. Now next one. How does A reaches part B? A is reaching the stigma by pollination. That is the transfer that is occurring from the anther to stigma. If it is same flower, self-pollination, different flowers of different plants, it is cross-pollination. In that itself, remember, there are pollinating agents. It can be biotic agents like animals, like honeybee and all. Or it can be abiotic agents like wind and water. So there are different agents of pollination. It can be wind pollination, or that is anemophily, water pollination, hydrophily, or it can be pollination by insects, flies, etc. or birds. Like that, different agents are there. Now, state the importance of part C, that is pollen tube. Pollen tube only carry the male gametes up to the ovule. So to the ovule, the male gametes are actually carried by the pollen tube. What about different flowers of the same plant? If you want to know, I will tell the term, but that is out only, Fatima. The term that is given for that is gytinogamy. It is genetically self-pollination, ecologically cross-pollination. I will go away from the topic. That is the reason, don't think much. Now, advantages of sexual reproduction. Sexual reproduction brings a lot of characters together. So it brings variation. And this variation helps in survival of the organism if it is better. So that are the advantages of sexual reproduction. Coitus interruptus is also a way of preventing. That is also a contraceptive method, natural method of contraception. We are not entering there. Okay, Maridan. Next one, mention the information source of making proteins in the cell. What is the basic event in reproduction? So basic event in reproduction is DNA copying. DNA in the nucleus of the cell, it has all the information about protein. So basic event of a reproduction is first one, DNA copying. Second one, multiplication of cell organelle. Third one, nuclear division. Fourth one, you can see there is cytoplasmic division. So all these things should happen. So in the DNA, you should understand different proteins informations are there. So surely next cell or the next organism also should receive this DNA copy. So cells use chemical reaction to build the copies of DNA and make this DNA copies so that they can pass it to the next one. And they also make additional cell organelles. So you write the main 2 points like this. DNA replication, because DNA carry entire information about the organism. Second one, to make all these proteins and all, we need additional cell organelle, endoplasmic reticulum, ribosome, Golgi apparatus, everything. So cell organelles are also replicated. That is the basic events associated with reproduction. Yeah, proteins are changing means variations will be there. Information of a protein is changing, protein also will be different. That means there can be dissimilarity, that is called variation. Now next one, write the names of those parts of a flower which serve as the same function as. Same function as the testis will be the stamen, in that anther. Then sperm, it will be the male gamete that is coming in pollen. Then ovary, you can see there will be ovule. Then egg is actually coming in the ovule, that is in the embryo sac. Embryo sac will be having the egg. Draw a labeled diagram of human female reproductive system. You know what is the labeled diagram? There should be a pair of ovary. From that there should be a fallopian tubule. Then there should be a uterus, then cervix, then vagina. Then here when you are drawing, draw some ligaments also attaching to the ovary, then label it. So it is attaching to the abdominal wall as well as the uterine wall. Then inside the uterus, you should be able to show some finger-like projections and all. That is the endometrium that is coming inside. So ovary, fallopian tubule, uterus, cervix, vagina. This much area you should be able to draw. Then what are the functions of testis in human male reproductive system? When you are writing about the testis function, you have to write about endocrine and exocrine function. Yes, Deepika, I saw the comment. Now I am moving. So here you should understand endocrine part of the testis will produce testosterone. That is responsible for producing all the secondary sex characters in male. It also helps in sperm formation, and also the secondary sex characters like the deepening of voice, appearance of beard, mustache, broadening of chest, etc. And even spermatogenesis and the sex organs development. That is the endocrine function. Exocrine part of the testis is associated with release and production of sperm. So like that, two things you should write when a question is coming regarding testis. Then why located outside? So here you should write about scrotum. You know that testis will be located outside the abdominal cavity in a pouch-like structure. The pouch-like structure where it is located is called as scrotum. So inside the scrotum only there is testis. Then from the testis you can see there is vas deferens that is passing like this. So in a person, understand there is a pair of kidney. From the kidney comes is the ureter. Then there is urinary bladder. Then next is the urethra. Like that it will be coming out. So in the person, this vas deferens, the green color what I have put is vas deferens, they form a loop around the ureter and they will be joining here in the urethra. In the urethra only the seminal vesicle is also opening, and here one more gland is coming, that is the prostate gland. So prostate gland is also opening up here. So understand, sperm from the testis is carried by vas deferens up to the seminal vesicle, where you can see they will mix up with the seminal fluid from the prostate gland and seminal vesicle, and it is passing through the urethra outside. So pathway of sperm and all sometimes may be asked. So you should be able to write is testis, vas deferens, urethra, and in between you should write seminal vesicle, prostate gland, as well as the Cowper's gland, like that. Then next one. So already we discussed what is responsible for bringing changes in appearance seen in boys at the time of puberty. You should be writing about testosterone. The hormone that you should write is testosterone. Now, why is vegetative propagation practiced for growing some type of plants? Already we discussed, in some plants the seed and the fruit formation or the flowering etc. will take a lot of time. That is one reason. Second, their seeds are not able to germinate well in particular soil. So these are the reason we go for artificial method of vegetative propagation in certain plants. So characters of plants can be preserved. That is one reason, because it is asexual. Then seedless plants you can grow well. Then it is cheaper and easier. Then cutting, grafting, all these flowers and fruits can be grown in a shortest time. So if a plant is flowering, fruiting etc. within 1 year, 2 years, if you want to multiply that plant in a short time, you can go for vegetative propagation. Second, it will produce the progeny same as the parent. Then third, you can see some plants produce seeds which will not be growing well in particular soil. So that also you can go for vegetative propagation. So these are the points associated with perseverance of genetic characters. Function of seminal vesicle and prostate gland, they produce seminal fluid. Seminal fluid will be having fructose and they will be nourishing the sperm, and it also help in easy movement of the sperm. That is also an expected question. Question was asked by Venkatesh. Shall I proceed? If you got this much, we will move to the next one. So longitudinal section of a flower, already we have drawn the longitudinal section of a flower. I think the same diagram we were drawing. There is pedicel, sepal, petal, stamen, as well as this pistil. That much is coming. Now next one, how are the modes of reproduction different in unicellular and multicellular organism? Unicellular organism, you can say method of reproduction either by fission, multiple fission, etc. only is coming. But multicellular organism, so in unicellular organism, gamete formation, etc. you cannot see. Or gamete formation and all, if it is coming, it's not that much complicated. But coming to multicellular organism, there is a lot of complication that is arising. They may be having specialized reproductive structures for producing gametes and all. Now, how many pairs of chromosomes? So this part before doing, let's actually do the sex determination. This is also an expected area. You know about autosomes and allosome. First few pairs of chromosome that is observed in us, that is responsible for all characters except sex, that is actually called autosomes. We have 44 autosome. And the last pair of chromosome responsible for sex characters is called allosome. It is X chromosome or Y chromosome. So in case of female, they are having 44 autosomes plus XX. And in males, you can see they are having 44 autosomes plus XY. And during gametogenesis, that is meiosis, they will be resulting in the formation of only one type of egg, that is 22 autosomes plus X. But here in males, you can see during spermatogenesis, it can result in 22 autosomes plus X or 22 autosomes plus Y. And if there is fertilization, this will be resulting in 44 autosomes plus XX, which can be a female. And if these two are actually fertilizing, what will happen? It is 44 autosomes plus XY that can be male. So this sex determination chart, you should have an idea. Then you just look at the question. How many pairs of chromosomes are present in human beings? You know, 46. 44 autosomes and 2 sex chromosomes. Out of this, how many are sex chromosomes? 2 are sex chromosomes. How many types of sex chromosomes are found in humans? 2 types, X and Y. A woman has only daughters. Analyze the situation genetically and provide suitable explanation. So that is a matter of chance only. We cannot actually tell it's because of this particular reason. It's a 50-50. Either it can actually fertilize the sperm with X from father or Y from father. If it is X coming from the father, surely it will be a female. If it is Y, then it will be a male. So that is the situation. Then what are the chromosomes? Chromosomes are actually condensed form of DNA. So DNA only highly condensed in order to form chromosome, and this happens during cell division. Explain how sexually reproducing organism maintain chromosome in the progeny. The answer is here. We are having 46. How it is retained in the next generation? Because only half the number of chromosome is going to our gametes. And this is due to which division? Meiosis, which we also can call it as which division? Reductional division. It's because of meiosis or reductional division, only half the number of chromosome will be coming in gametes. And when they fertilize, it will restore the chromosome number in next generation. That's all. So this is what you should write. Venkatesh, got it? During cell division, whether meiosis or mitosis will both occur. During gamete formation, it is meiosis. After zygote formation, it is mitosis. So restoring the chromosome number is done by meiosis. That is the answer. Hope you got it. Okay, hello world. No need to comment that type of things. Now next one. In one of his experiments with pea plants, Mendel observed that when a pure tall pea plant is crossed with a pure dwarf pea plant in the first generation, F1 only tall plants appear. What is the reason? You know that when a tall pea plant is crossed with dwarf pea plant, if you are getting all tall in F1, what is the reason? This is homozygous. Here, understand, when two different genes are coming, one is only expressed and the other remain suppressed. The one which is expressed is called which one? One which is expressed is called dominant. One which remains suppressed is called, what is it called? Recessive. One which remains suppressed is called as recessive. This is law of dominance. So here the first question is regarding, they are asking about law of dominance, and you should write about recessive also. See, in F1 generation only one gene is expressed and the other is suppressed, means understand the one which is expressed is dominant and one which remains suppressed is recessive. The next one, what happens to the traits of dwarf plants? Actually, here the dwarf genes are remaining silent. They are recessive. They can express only in homozygous condition. It happens in next generation, that is F2. Then when F1 generation plants were self-pollinated, he observed that in plants of second generation, both tall and dwarf plants were present. Why it happened? Explain briefly. So the same reason only. In F2 generation, the recessive characters appeared because they were homozygous. You know what will happen in F2 generation. In F2 generation, you will get this genotype 1:2, 2:1, or you will be getting 3 tall plants and 1 dwarf plants. So dwarf expressed because it was homozygous. So when you are learning this, learn terms like this. What is dominant? The gene that is expressing in heterozygous condition as well as homozygous is called dominant gene. The one which remains silent in heterozygous can express only in homozygous condition is called recessive. So that is also what you should learn. Dominant. Yeah, that's the answer. So this cross also learn correctly. Surely it will be coming. Learn the 7 pairs of contrasting character. Stem height, tall dominant, dwarf recessive. Seed shape, round dominant, wrinkled recessive. Seed color, yellow dominant, green recessive. Yellow dominant, green recessive. And the pod color, green dominant, yellow recessive. Flower color, violet dominant, white recessive. Flower position, axial dominant and terminal recessive. Pod shape, full dominant, constricted will be recessive. These 7 characters you should learn. Shall I proceed? 7 characters. Hope you got it. Then one more question. Why he selected pea plants? You should write short lifespan, easily available, and these pea plants are bisexual flower which can undergo self-pollination, but we can also perform artificial crossing between the flowers. That is why Mendel chose pea plant. And ultimately I can tell it had 7 pairs of contrasting character. This is the reason pea plant was actually selected. Law of segregation. 2 genes you can see, they never remain together. This capital T and the small t here will never remain together. They get separated during which formation? They get separated during the gamete formation. They get separated during gamete formation, like that. So this chart was, okay, selfing is done. You can see it will be coming like this. So here, this chart is wrong. Let me show which is the correct one. Punnett square, already you may be knowing what is coming in the Punnett square. So here, monohybrid experiment, you have to write male and female gamete. Male gamete can be capital T, small t. Female gamete also will be capital T, small t. So here it will be 25% homozygous tall, 55% heterozygous tall, and 25% homozygous dwarf. So remember, 2 genes or factors, they never remain together. They get separated during gamete formation. That is law of segregation. Sorry, is chromosome made up of genes? Of course. So for that question from a guest person, let me give what is chromosome. In a chromosome, you should understand there is DNA. So homologous chromosome, if you are taking, you can see in a chromosome, especially the homologous chromosome when you are taking. So what is homologous chromosome? Homologous chromosome, one chromosome is from father, that is paternal, one chromosome is from mother, that is maternal. In that actually DNA is coming. What is coming? DNA from father and DNA from mother. So these DNA segments are actually called what? This DNA segments responsible for a character is called as, what is it called? Gene. Hope you got it. And at this location, suppose stem height gene is coming in pea plant. Two possibilities there, either tall or dwarf. Here also two possibility, tall or dwarf. Like this alternate form of a gene coming at same location in homologous chromosome is called as, what is it called? Alleles. So what is allele? Don't simply write alternate form of a gene. It is alternate form of a gene present at same location of which chromosome? Homologous chromosome. That is what we call it as alleles. Then dihybrid cross, much I am not telling. I will just write a cross dihybrid. Hope you know the phenotypic and genotypic ratio. Can you comment the phenotypic and genotypic ratio for a dihybrid cross? Dihybrid cross for stem height and seed shape if you are taking. So when you are writing, first you should write the parents. In the parents you should write the phenotype. Then you should write the genotype. So stem height if I am taking, let me write about the tall and dwarf. Then round and wrinkled. So tall, if I take capital T, capital T, capital R, capital R, here I should take small t, small r, small r. And what should be the gamete here? Gamete has only one gene from a character. So after artificial cross, you can see F1 generation will be having tall, round. Then what is F2? Let me check the comments. Who all got the answer? Let me see. Yes, first answer by Fatima, 9:3:3:3:1, that you will be getting. In that, 9 will be tall with round and 1 will be dwarf with wrinkled. Remaining 2 you can see new combination, that is tall with wrinkled and dwarf with round. Hope you got it. So this is the phenotypic ratio. Genotypic, many are commenting, very good. 1:1, 2:4:2, 1:1. Yug has commented first, that is the answer. Now one expected question from this area is test cross. Test cross means if you are crossing a tall plant with dwarf plant and you are getting 50% tall and 50% dwarf. What is the genotype of this plant? Surely dwarf plant is homozygous. What should be the genotype of this plant? So if you are getting a 1:1 ratio, what is the genotype of this plant? I need all of you to comment. Let me check who is going to comment first. Very good. Deepika got the answer first. The answer is heterozygous. So hope you got it. Why it is heterozygous? If it was homozygous, you will not be getting dwarf plants. If it was homozygous, you will not be getting dwarf plant. This cross only we call it as test cross. So dominant character, the genotype is not predictable. You cannot see inside the plant. So what you should do is cross it with the recessive parent. And if you get 1:1 ratio, then understand the plant picked by you is heterozygous. That's it. Very simple. Now, expected question from the final chapter, our environment. So only few questions here. You already know about the trophic level. What will be the amount of energy available to the organism in second trophic level if the energy available at first trophic level is 10,000 joule? So what is coming in first trophic level? So what is trophic level? Position of an organism in the food chain is called as trophic level. First trophic level is occupied by primary producer. First trophic level is occupied by primary producer, which include autotrophs. And which autotrophs are generally coming? Plants as well as photosynthetic bacteria. Let me write one. A grass. Now, what is coming in the second trophic level? I am drawing a pyramid of energy only. Then second trophic level is occupied by the primary consumer. Which is the primary consumer? Herbivores. Let's write it as grasshopper. Now, next trophic level you can see it is occupied by third trophic level. It is secondary consumer. What is it? Secondary consumer, that is primary carnivore. That is primary carnivore. Let it be frog. Next trophic level, if you take the fourth trophic level, it is occupied by tertiary consumer, that is secondary carnivore. That is secondary carnivore. Let's take some snake. Then last is the top consumer. The top consumer is tertiary carnivore, and it is the fifth trophic level. Let's take an eagle. So if I am taking 10,000 joules of energy in the first trophic level, only 10% will go to the next one. What is the 10%? It will be 1000. So answer to this question is 1000. Hope you got it. Next we will get what? 100. Next we will get what? 10. Next we will get what? 1. So there is answer to many questions in the chart. Why the trophic levels in a food chain is decreased to 4 or 5? Because that much energy won't be reaching the top trophic level. That is the reason. So hope you understood the trophic levels, and in each trophic level which one is coming, and example of all of them, and the 10% law given by Lindemann. Is this much clear? Please comment. Oh, answer came first of all. So many answered. Harry have commented it many times. Then sir, why is aquarium cleaned but not a pond? Aquarium you have to actually clean it in order to remove the excretory waste and all. But if you are keeping a lot of plants and all, they will consume it. So an ecosystem, if you are able to build it up, you don't have to clean it. But in the pond, it is a natural ecosystem where there is nutrient cycling. You don't have to clean it. The waste that is excreted from different organisms is uptaken by the plants and used it. So like that it is happening naturally. In aquarium that much time is not there. That is why you have to clean it. Otherwise you should give them enough time for this to take place. Shall I proceed? Ponds and lakes being natural ecosystem have natural decomposers. That is the answer. Natural decomposers are there for nutrient cycling. Yeah, I got. Shout out. What is happening? Okay, Harry, it's okay. Now listen. Now, one more thing. If I am spraying excessive DDT, a toxic chemical I am spraying on the grass, slowly you can see it will start accumulating in the tissues of this top consumer. It will give so many defects in the top consumer. What is that process called? Blood group crossing and all. Why it is required? If you want, I will tell. No issue. Let me finish it. The class is going to wind up. If you want last one blood group, I will tell. Okay, the answer from Deepika, that is the answer, biomagnification. Biomagnification is the process that is actually happening here. So what is biomagnification? It's an expected question. So accumulation of some toxic chemicals in the tissues of organism that are present at highest trophic level, that is called biological magnification or biomagnification. Hope you got it. Now last topic, ozone. Formation of ozone and what are the uses of ozone. So ozone is actually formed when oxygen is combining with O2 you can see the O3 will be formed. It will be protecting us from the UV light. So if there is depletion of ozone by chlorofluorocarbons and all, you can see so many defects can be seen in the organism. So what are the defects that can be seen? One is skin cancer. Then it can cause damage to the eye, that is cataract, and it also can damage your immune system. So these are the defects that you can actually observe. So this much is the expected questions from bio. I think I have touched almost all the areas in this short session. Hope you got it. Eye color and all, if it is given in NCERT, they will be giving it as one dominant, one recessive. Using that you can do same only, Deepika. Shall I proceed? Is this much enough? Have you got it? So capital B is for dominant and small b for recessive, like that it is coming. Okay, then those who need blood group, please comment. If more than 10 people is there, we will do blood group also. Blood group, blood group. Let's see who all want it. No one. So many were asking in the beginning, blood group detection, etc. Okay, only Anne Mary. Venkatesh. Okay, Harry, Fatima. Okay, let's discuss blood group also. Blood group in humans is an example of multiple alleles. So what you may be thinking, what is multiple allele? That means in a chromosome usually for a particular character, a gene can have two forms. But if a gene is having more than two forms, like this blood group, you can see there is IA gene, IB gene, IO gene. So like that, more than two forms of a gene is coming in a chromosome. That is called multiple allelism. Now coming to the blood group, don't leave, I have something to speak also. So in blood group, it's mainly based on, the blood group of a person is mainly based on antigen on the surface of RBC. A person's blood group is said to be A if the surface of RBC contain which antigen? Surface of RBC contains, so I am drawing it very large, it contains which antigen? A antigen. And suppose the surface of RBC is having B antigen. I am drawing a different shape for surface antigen. So this one is B antigen. I am just drawing it enlarged, don't think it is exactly like this, it's very minute only. So this is actually B antigen. But in some people you can see the surface of blood cell will have both A antigen and the B antigen. Like that both are coming. That blood group is called as AB. Then those people whose RBC surface is not having any antigen, that is called O. Then you should understand their body will also have what? Antibody. People with A blood group will be having B antibody. B blood group will have A antibody, otherwise it will clot. Then here no A and B antibody, here both A and B antibody. So this is blood grouping. Now let me tell which genes are responsible for this. Genotype also. So what I have written is the phenotype. Now let me tell about genotype. A blood group person, either it should be getting IA from father and mother or IA and IO, because IA is dominant over IO. Got it? Now B blood group, B antigen is formed by IB gene. Either they are having IB in homozygous condition or heterozygous condition. Then B is also dominant over IO, but A and B when comes together, A gene and B gene, when it is coming together, both of them will express. Then IO, when coming from father and mother, no surface antigen is coming. So this is the genotype, phenotype, antigens. That's all about blood group. Have you got it? Please comment. Then using this, you can do the problems associated with blood groups and all. So I'm not going to spend much time on that. You know how to do it. Shall I? I want to see the comments. Please comment fast. Can you comment? Yes, got it. It's not going to come. I'm also not expecting much. Now, we are winding up our sessions. So let me tell all the best to all my students who are actually preparing for this exam. And we know there is a lot of hard work behind all this, and you can all try nicely for tomorrow. So from the beginning, when you are writing the exam, be very cool and attend first those questions which you know nicely. Then try to do a good presentation for your exam. Don't actually make cut and all when you are writing, drawing, etc. Make it very good looking. And write point wise also. Avoid paragraph mode of writing and all. So I'm winding up my session. Thank you all and all the best again. Bye.